Hey guys, welcome to this live session from Edureka on AWS. Today in this session, we're going to see how you can secure your AWS account using the AWS IAM services, right? So let's go ahead and see what is our agenda for today to see what all we are going to cover in this session. All right, so we're going to start with why do we need access management and then move on to what is IAM. After that, we're going to see what are the components, what are the different components of IAM, and move on to discuss the multi-factor authentication service offered by IAM. And towards the end, we'll be doing a hands-on wherein we'll be creating, or I'll be demonstrating to you an application which will upload your files to S3 using the IAM policies. Alright, so guys, this is our agenda for today. I hope it's clear to you. Alright guys, so I welcome you all to the live session. Any doubts that you have during the session, please put it down in the comment box. My team is here to help you out. And anywhere if you feel, if it is not a live session on your side, anywhere if you feel you have a doubt, please put it in the normal comment section and we'll be happy to answer it for you. Alright, so let's go ahead and start with today's session with the first topic, which is why do we need access management? Alright, so to discuss this topic, let's understand it using an example. Say you have a company in which you have a server, and this server has everything in it. It has all the modules in it, and it gives you it gives different users the permission to use the different servers, right? Now, in your company, first of all, you should have an administrator which will have all the rights to access the server, right? So nobody in the today's IT world works on the root account, right? So there has to be an administrator account. So first we will create an administrator account with all the permissions. Now tomorrow, say a UI developer comes into your company, right? Now a UI developer will only work on the graphical tools, right? So he should only be allowed the graphical tools and not some other tools. Maybe he shall not be given the internet access or something like that, right? Maybe he's not giving the PowerPoint access, maybe he's not given some folders access, some drives access, anything like that. So all of that can be defined in the server by the administrator, and specific rights will be given to a UI developer, right? Similarly, if after that a business analyst comes in, so he should only be able to access the analytics module which is there in your server, right? He should not be able to get into the UI development part, or he should not be able to see the other aspects of what is there in your server, right? So each and every user or each every role will have specific rights assigned to them, right? And this is done by policies which are in turn given by administrators, right? So this is what access management is, that giving each role the specific rights that they deserve. And this is what we are going to accomplish today in AWS, right? So this is why we need access management. Let's go ahead and understand how can we accomplish this in AWS, right? So to accomplish this in AWS, you need a service called IAM. You have a service called IAM which uses this concept of access management and allows you to give it to your users who are going to use your account, right? So what is IAM? So IAM is basically a service from AWS using which you can give permissions to different users who are using the same AWS account that you have created, right? So in a company in any company, be it, you don't have to have 2 or 3 AWS accounts. You can have one AWS account on which a number of people can work, right? For example, you can define that maybe a developer would like to work on your AWS account, and he should only have the EC2 instances, or he should only work on the EC2 instances. You decide that, right? So you can define a policy like that, that only the developers will only be able to access the EC2 instances on your AWS account. Similarly, if say a database administrator comes in, so he should be only able to access the DB instances on your AWS account, and so on, right? So all of that is possible using IAM. But IAM is not only about creating users and creating policies. It's more, there is more to IAM, right? And hence we'll be discussing the different components of IAM now. So let's go on and see what are the different components. So there are basically 4 different components in the IAM service. So the first service is user, then we have groups, then we have roles, and then we have policies. Right, so the way we are going to go about these are, first I'm going to explain you each role or each service in IAM, each component in IAM, and then we're going to see how we can execute them or create them in the AWS console. Right, so let's start with the users. So the very first time you actually create a AWS account, that is basically the root account that you have created, right? So there is no user inside it. So why do we basically need a user? You need a user because you are supposed to give permissions to someone, right? So say I first of all want to give administrator rights to a user, right? So you understand, you have to have an entity first to which you can assign permissions, right? So these entities are called users on AWS. So any person who wants to access your AWS account has to be added as a user in IAM, and then you can attach different policies onto that user. Alright, so this is what user is all about. Let me go to my AWS Management Console and show you how you can create a user in IAM. Alright, so give me a second. Alright guys, so this is my AWS sign in page. Alright, so this email ID, when you log in through your email ID and your password, that is basically your root account. So what I'm going to do right now is I'm going to log in using my root account and first create a admin account for myself. Alright guys, so you should never work in your root account. You should always have an administrator account through working. The root account should only be used when there is an emergency. Say you have been logged out of your administrator account, only then you should be using your root account. So the first thing that you should do when you enter your root account is go to IAM, which is just right here. Go to IAM and then you will have this dashboard thing, right? Over here you can see there is a thing called users. You will click on users and you will click on add user. Alright, so now it will ask you for the username, so you can provide a username. Say I'll add my name first, so that be Hemant, right? And what kind of access do I want to give to this particular user? So there are basically two kinds of access that I can give. First is the AWS Management Console access, and then we have the programmatic access, right? So what is these two? If you want to, so there are basically two ways you can access the AWS resources, right? You can either access them using APIs, that is using your code. Say you have created an application which is interacting with your AWS resources, right? So in that case, if you're interacting with the APIs, using the APIs, that is called the programmatic access. Right. Secondly is the AWS Management Console access. That is when you are using the AWS website to actually deploy resources or create or remove policies or whatever. Right. So that is called the AWS Management Console access. So for my user, I'd be giving it both the accesses, that is programmatic access and the management console access. Also guys, when you enable the programmatic access, basically you get the access key and the secret key as well. What are these? I will be explaining you in a bit. Alright, so we have selected both of these options and then move ahead to choose the password. So do you want an auto-generated password or a custom password? I'll choose a custom password since I'm creating account for myself, right? So I'll choose a custom password. And do I want to reset the password on my first login? No, I don't want that. So I'll click on next permissions. All right, so what kind of permissions do I want my account to have? I will be configuring that over here. So as of now, there are no groups. There is no existing user that I can copy from. So I'll attach existing policies, and since I want to attach the administrator access, that is the first policy over here, I'll select that and click on next. Alright, so you can review all the settings that you did over here and click on create user. This will create a new user in your AWS account. So as you can see, I have got my access key ID and a secret access key. Now guys, the secret access key, you only get it to see one time, only one time when you have created your account. So it is essential that you store your access key and your secret access key once you get this page. Alright, so let me store it quickly. So this is my access key ID. Why we are copying it, you'll get to know during the session. Don't worry. And my secret access key, which is this, so let me copy this and paste it in the notepad. All right, so don't worry. You might be thinking that I've exposed my secret key to you, so I'll be deleting this account afterwards, so you don't have to worry about that. All right, so I've got my access key ID and my secret access key, so that is done. Now what I'll be doing is I'll be logging out from my root account and logging in this user account that I just created. All right, so one more thing that you have to be very careful of, that you will not be logging in through the same login page that you just saw, right? So you'll have to log in through a different login page now, and the URL for that is this, right? So you'll be logging in through this link as of from now on. So whenever you create a user, if you want them to log into your account, you have to give them this link to log into, right? So let us copy this link over here and log out from our root account. All right, so I've logged out. I'll close this and I'll come here and go to this particular link. Alright, so once you reach this particular link, it will be asking you the account name, which will be self-filled by your link, right? So you have to give your username now, which is Hemant, and then the password. So I'll type in the password that I've given it and click on sign in. So now I have basically signed in to the user that I've just created on my root account. Right, so I no longer have to use my root account. I can basically lock away my root account for emergency purposes. I'll be using my administrator account from now on. I can do everything from my administrator account that could be done from my root account as well. But there are cases wherein you get locked out from your administrator account. In that cases, you will be needing your root access. All right. So moving on, guys. So I'll go to IAM now. So as you can see, we have created a user and we have logged into that user. And if I go to IAM now, you can see that it will show that one user has been created. That is here. All right. So let's get back to our slide and discuss the next component. All right. So we've discussed what are users. Let's move on to the second component, which are groups. Alright, so whenever you create users, they can also be combined into groups. Now, why do we need groups? We need groups because, let's take an example. So say you have 5 users and these 5 users have to be given identical access, right? Say these 5 users belong to the development team and the development team has to have some common access that they all will have, right? Now, one way of doing this would be that I would go to each and every user and attach a policy that they need. Right, the smart way to do this would be to include them inside one group, and to that group I will only once I will attach the policy and it will apply to all these 5 users, right? So these are why groups are very important. Now how we can create groups, let me shed a light on that. So you will go to you can see you can click on groups over here, and what you'll do basically is you'll click on create new group. All right, so let me give the group name as live demo. All right, and I'll click on next step. Now it will ask me the policy that I want to attach to this particular group. All right, so say for example I just want this group to be able to access the S3 service from AWS. So what I'll do is I will select the policy which says Amazon S3 full access, and I'll click on next step. Now this policy basically tells you that you're going to only use the S3 service in the management console and no other service. All right, so I'll click on create group, and now whichever user I will be putting inside this group will have this property. All right, so I don't have to configure the policy for any user now. So what I'll do is I'll create a new user now. So say I create a new user saying test, all right, and then I'm not giving him the programmatic access, I'm just giving him the management console access. All right, I'll click on this and I'll give it a custom password, and then I don't want him to reset his password. I'll click on next, right? And now it is asking me whether I want to include it inside a group. So yes, I do. I want to include it inside the group that I've just created, and I'll click on next and review all the settings that I've just did and click on create user. Alright, so the test account has just been created. Now, as you can see, guys, in the case of my account, which I created, I got an access key and a secret access key, right? So in this case, I'm not getting any because I didn't select the programmatic access. Only when you select the programmatic access, it will give you the key so that your application can actually interact with the services that you have launched. Alright, so I've created a test user successfully. Let's log into this test user. So I will type in the URL that has been given to me. Right, now when I reach this page, I'll enter the username as test and the password as what I have entered, right? And I'll click on sign in. Now with this, you can see that I will now be able to see the management console. The management console will exactly look like how it was used to see, how I used to see it in my root account or my administrator account. But when you will try to access, say, a service which you have not been assigned to, say for example, I only have access to S3 right now because I've deployed it in the group where it has only the access to S3. If I try to go inside EC2, let's see what will happen. Right, so it says you're not authorized to describe running instances. As a matter of fact, I'm not authorized to see anything on my EC2 page. All right, so that is because I don't have access to the EC2 dashboard. But let's see if I can see the S3 dashboard. So I'll quickly go to S3. And if I have the S3 access, I'll be able to see all the buckets which are there in my S3. And yes, I do. So let me go inside a bucket and delete something so that, all right, so let me delete an object from this particular bucket. So yes, I can delete it. All right, so let me check if what happens if I delete or I detach this particular policy from that group. All right, let's see what happens. So I'll go to IAM and I'll go to groups. I'll go to this particular group and I can see that the policy is listed over here. What I'll do is I'll click on detach policy and let's see what happens now. Right, so I'll go to management console. So if now I try to access S3, it will show me that access is denied. Right, so I no longer have access to the S3 service on my AWS console. So this is how you can control access to different users. You can revoke access, you can include access, right? You can do all of that in IAM. All right, so let us come back to our slide to discuss our next component. All right, so we've discussed what are users, we've discussed what are groups. Now let's come down to roles. All right, so roles are similar to users, but roles are actually assigned to applications. All right, so users are actually assigned to people, right? So whenever you have a developer in the company, you will assign him the developer roles, right? But when you have roles, roles are basically assigned to applications. How? Let me explain you. Say you create an EC2 instance, and inside that EC2 instance, you're hosting a web application. Now that web application has been designed in such a way that it has to interact with your S3 services, for example, that we'll be doing today. I'll be showing you the demonstration today for this, right? So say that application has to interact with the S3 service. Now, if I want that application to interact with the S3 service, I have to give it permissions. And to give it permissions, I will use role. So I will create a role wherein I will specify that this role can access the S3 service, and I will attach this particular role to that particular EC2 instance in which my application is hosted. And in that case, my application will be able to interact with the S3 service. Right? It might sound complicated, guys, but it is very easy to implement. Let me show you how. So what I'll do now is I'll go back to my management console, which is here. All right, I'll go to the dashboard and say I'll go to roles now. All right, so I'll create a new role. Now roles can be assigned to any AWS service which is listed here. What I'll do is I'll assign it to I'll create a role type of EC2. All right, so I'll select Amazon EC2, and what type of role do I want to apply it to? I want to say have the access to S3, right? So I'll select Amazon S3 full access over here, and I'll click on next step. So it'll ask me the role name. So let me specify the role name as edureka_1, right? And I'll click on create role. So with this, a role has now been created, but mind you guys, I've not attached this role to any EC2 instance, right? So what I'll do now is I'll go to my EC2 console. So over there, I already have built an EC2 instance. It is stopped, so I'll start it and attach this particular policy to that EC2 instance. Alright, so my EC2 instance name is Hemant_1. So here it is. I'll go to actions. I'll start this particular instance. Right, and what I can do is I can attach the policy using instance settings. It says attach or replace IAM role. I'll go here. I will go to the drop down and select the role that I've just created, which is edureka_1. I'll select that and I'll click on apply. Now with this, what will happen is my role is now my EC2 instance is now configured to interact with the S3 service in this particular account. Alright, so any application that I deploy in this EC2 instance will be able to interact with the S3. Okay, so I don't have to specify any access key, any secret access key. If you're still confused with that, be patient. We are getting on to where do we actually use these keys and where do we not. Alright, so this is what your roles are all about, right? So roles, like I said, they are for resources in AWS. Users are for people. Roles and users are similar things. You attach policies onto them, and they basically identify a particular instance or a particular person as the owner of that particular service, right? So I've discussed what roles are. Let's move on and discuss policies. So if you think about it, guys, we've actually been dealing with policies, right? So policies are nothing but permissions that you give to your with whatever role or user or group that you have created, right? So for example, I want to give the EC2 instance access, right? So that EC2 instance access is basically a policy that I'll be attaching to the user or to the roles. All right, let's see how we can create policies, guys. So I'll go to my management console. I'll go to IAM. Right, so you can either create policies or you can actually use the already existing ones. So there are a couple of policies that have already been created in your AWS account, but you can go ahead and create your own policy as well. All right, so let me show you how. So say for my test account, what I'll do is I will go inside test account. Alright, and I will add permissions and I will attach existing policies directly, and here I am, guys. So now you can create policies as well. So you see the tab over here, guys, it says create policy. So if you feel the kind of policy that you want to create is not listed over here in the default policies, you can actually create one. And creating a policy is very easy, guys. You'll just click on create policy and you will see this page. Alright, so you'll have three options. You can either copy an AWS managed policy, that is a default policy. You can create your own policy by just typing in the JSON code. And if you're not comfortable with coding, what you can do is you can use the policy generator. Now what is policy generator? Let me explain you. So with policy generator, you just have to select what effect do you want. Do you want it to allow it or do you want it to deny it? Right? So say I want to allow the EC2 service to this particular test account. Alright, so I'll go to EC2. Alright, here it is. I selected EC2. What kind of actions can he perform? Say I want to give him all the actions. You can do anything with EC2, and resource name is basically a particular resource. So with ARN you can identify a particular resource. So I don't want a particular resource to be assigned to him. I want he can access every resource in EC2, right? So I just add star for all of them, right, and click on next step. So with this, as you can see, it has automatically created a policy document for you. All you have to do now is click on create policy, and it will create the policy for you. So as you can see, there were 18 customer managed policies. There are now 19. So I can go here and select the policy over here. All right. So if I go to my user now, which is test, and go to permissions, I will just click on add inline policy, click on select, again go to EC2, select actions, all actions, right, and put it to star. So I'll click on add statement, click on next step, and click on apply policy. So a policy has been applied on the test user that it can actually access the EC2 instances now. So if I go to my test user now, in which I was not allowed to access the EC2 instances, I can actually use the EC2 instances now. So if I go to EC2, you can see it will not give me the access denied thing, right? So I can access all the instances over here as if I was using the root account, but only for the EC2 service, right? If I go to S3, you can see I will still have the access denied page because I've not been assigned the access to this particular service. All right. One more thing, guys. What if you add an allow and a deny policy together inside a group? What will happen then? So in that case, so since I have allowed EC2 access, what I'll do is I'll deny EC2 access as well in this particular user. So I'll create one more policy and I'll say deny. I'll select EC2. Right, I'll select the actions as all actions. I'll give the resources all, add the statement, and click on next step, apply the policy. So now I have denied EC2 instances as well and created and allowed EC2 instances as well. What do you think will happen now? So if now I try to go to EC2, let's see what will happen. So it will say you're not authorized to use EC2 anymore, because whenever you're creating policy, guys, you either get the allow option or the deny option. If you have selected both of them, it will always prefer the least permission that you have given. So in our case, that is the deny option, right? So it will always deny the case even if you have allowed it in the same user, right? If you have mentioned that that particular service has to be denied to that particular user. All right, so this was about policies, guys. Let me come back to my slide. So we have discussed what are users, what are groups, what are roles, and what are policies. Let's go ahead and discuss the very important part of authentication, which is called the multi-factor authentication. So what is multi-factor authentication, guys? So multi-factor authentication is basically something like OTP that you get when you're logging into your Gmail account, right? So you enter your Gmail email ID, you enter your password, and when you click on continue, it will ask you for your OTP, right? So same is the case here as well. You can configure your AWS account in such a way that you will enter your username, you will enter your password, and when you click on login, it will also ask you for a code that has to be given to it. Now that code is basically the multi-factor authentication thing that we're talking about. So there are basically two layers of security now. One layer is a password and second layer becomes the code that you'll be entering, right? Now with AWS, there is an application called the Google Authenticator, right, which you can use to create a virtual multi-factor authentication device. Now, for those of you who already are using multi-factor authentication in your companies, so there's a thing called Gemalto, right? So people who work from home and they have to connect to their company's network, the way you connect it is using a Gemalto token, right? And so those of you who are from the IT background, you can relate to it, right? But if you want to go through a simpler way, you can actually create a virtual multi factor authentication device. And to create that in your AWS is pretty simple. You just have to download an application called Do Google Authenticator on your phone, and you have to connect that application to your AWS account, and that is it. Now it might sound tough, but it's very simple. Let me show you how. So you will basically go to your AWS Management Console, and you will go to the particular user that you want that multi-factor authentication to be assigned to. Right? So for example, I want it to be assigned to the test user, right? So what I'll do is I'll go to users, I'll go to test, right? And in the security credentials tab, I will have this page which says assigned MFA device. So it says no as of now. So I'll assign it a device. I'll click on edit. And now it'll give me an option between a virtual MFA device and a hardware MFA device. Now I have to choose among the two. So since I said you can create a virtual MFA device very easily, so I'll select the virtual MFA device. And now it is basically asking you to install the application on your phone. So we have already done that. Let's click on next step, and now you'll be presented with the screen. So basically now what you have to do is you will be logging into your Google Authenticator app, and you will be scanning this barcode from your phone. So let me show you how. Let me connect my phone to the computer so that you can see the screen. Give me a second. Alright, so this is a screen to my phone, guys. So what I have to do now is I'll have to go to the Google Authenticator app, and it'll ask me to create an account. So I'll click on begin, and once I have that, basically now I'll have to scan the barcode from my mobile. So the way to do that is I'll click on scan a barcode, and then I'll scan this barcode over here. Right, it might take some time, so be patient. Yeah, so it's done. Now you're all set, right? So you'll just click on done, and now you have to enter two codes that you will be receiving on your Google Authenticator. So basically these codes change from every 30 seconds, right? So I have to enter these codes over here. So it's 204 and then 020 and 353. 020 353, and I have to enter the next code as well. So let's wait for the next code, and it's 127891. So I'll enter that over here as well. So it's 127891, and that is it, guys. So now I'll click on activate virtual MFA, and it says the MFA device was successfully associated. So I'll click on finish, and that is it, guys. You're done. Right, so now if I log out from my test account, that is from here, right? This is my test account. So if I log out from here right now, and try to log in again using test, so I'll come to my normal login page, right? So I'll enter my username and my password, which is this, and now I'll click on sign in. So now it'll ask me for the MFA code. So let's see what is our MFA code as of now. So it has changed to 734552. So let us enter that, 734552, and click on submit. So with this, I'll now be able to log in to my AWS console using the test account which I configured using the administrator account in IAM. Alright, so it's very simple, guys. You can actually get world-class security with the click of a button using IAM. Alright, so uh, we have seen how we can do multi-factor authentication. Let's move on to the hands-on part now. So this is what is you guys have been waiting for. So just give me a second so that I can configure everything on my end. Alright, so what we'll be doing now is I have created an application which can interact with the S3 service. Alright, so using that S3 service now, we'll be uploading files to our S3 console. And how we are going to do that? First, we are going to do that using localhost, and that is where our secret keys and my access key comes in. And then we have assigned a role to our EC2 instance, right? So we'll be accessing that website using EC2 without the access key and the secret access key, and we'll see, do we get the access to our S3 service or not? All right, so let us do that. So now what I'll do is I will go to my localhost application. So guys, this is basically my application. What I have to do is I'll choose a file, I'll upload a picture from any sample pictures, and then it'll upload it to a particular bucket that I've defined in S3, and that the bucket looks something like this. Right, so that bucket's name is quarantine demo. So let me show you the bucket. So as of now, I think there are some objects, so let's delete those objects. So here it is. This is the bucket quarantine demo. So I have like 3 objects over here as of now. So let's delete these objects. Alright, so now what I'll be doing is this is the code for my application, guys. Alright, so in this code, as you can see, I have not specified the key and the secret key as of now. So I'll get the key and the secret key from here, right? So let me show you without the secret key and access key how is this localhost website functioning. So if I try to upload a file as of now, say this is the file that I want to upload, I'll click on upload image, and I'll get an error, right? Because it is not authenticating itself to the service that I want to go to. So now I'll add the credentials, that is the key and the secret key. Now the way to do that is like this. So I'll copy it and I'll paste it here. I'll delete this and this as well, not required. And now I'll paste my key and my secret key, which is this. Right, so I'll copy the key over here, and then my secret key as well over here. And now I'll save it, and if I try to access my localhost website now, I should be able to upload a file, right? So if I try to upload the file now, it says well done, S3 upload complete. So these credentials that I've just entered are basically credentials for my Hemant account. So if you want to see where did I get these credentials from again, you can basically go to users, you can go to your user, and you can go at security credentials, and over here it will list you the access key ID. It will not list you the secret access key because it is only available once. You can only use it once. Copy it once, you will not be able to see it again. And if I make this particular key inactive from over here, and if I try to upload anything again, I will again get an error because without the keys my account will not be authenticated to the S3 service. So as you can see, it says invalid access key because it is not valid anymore. Alright, so I can make it active again, but that is not required as of now. So what I'll do now is I've already configured this website on the EC2 console. Alright, so let me go to my EC2. right? Here it is. So remember, in the starting of the session, we created a role for S3 full access, right? So that role has been attached to my EC2 instance. So let me show you the website. Here it is. Alright, so I can access the website on my EC2. Now, if I choose a file as of now and I try to upload the file, I'll be able to do so because my policy has been attached. Now, let's see what happens if I detach the policy, right? So I'll go to this and I'll select no role, click on apply, yes, detach. And now if I try to upload a file again, as you can see, I see a blank page, which basically means that an error has occurred. Alright, so I am not able to upload any file because my role has been detached from my EC2 instance. So if I want it to be working again, I'll just simply go here, go to actions, settings, attach the role, that is this, click on apply, and it'll again work. Right, I'll choose a file, say this file, upload the image, and it'll work again. Works like a charm, right? So that is it, guys. You don't have to configure much. You just have to have the knowledge of IAM, and with that you can do complex procedures with the click of a button, and you don't have to swear about it. All right, you might be wondering, did I change anything in the code when I uploaded it to EC2? So you don't have to do anything, guys. You just have to delete the credentials, key, and secret, and you will upload the code as it is. You don't have to change anything. If it doesn't have the key mentioned in this particular function, it'll basically get those keys from the metadata of EC2, and metadata is the place where your role is actually assigned, or your role is actually attached, right? So if it doesn't find the key in the code, it basically goes to the metadata and picks the key from over there. Alright, so guys, that is it for the demo part, and that is it, guys. So that is all for today's session. I hope you learned something new today, guys. Now, before ending the session, let me quickly show you, if you are keen to learn AWS, we have quite a few resources on AWS that you can go through. So on YouTube, we have a playlist on AWS which has around 47 videos for you, right? So if you want to learn more about AWS, you can go through these AWS videos and learn more. Any doubts that you have among any of the videos, you can put it in the comment box and we will reply as soon as possible. All right, if you are into reading, we also have a blogging section on AWS. You can go through the blogs and get an introduction to AWS. And if you are interested to get certified in AWS, we also happen to offer a course, right? And you can go through the course details here. We actually have flexible batch timings. Because we know you as professionals, you can't attend a class during your office, and hence we offer classes during the night time and the morning time as well. If you want to learn more about the course, you can go here in the course description page and learn more about the course, right? Also, guys, if you want live notifications, if you didn't get one and you want live notifications prior to a session that we have on YouTube, you can go to this particular page, which is resources.edureka.co/edureka live notification. Register yourself up here and choose a topic that you want the live session to attend on, right? So whenever we have a live session assigned to this particular course, we will send you an email prior to that session, say around 3-4 hours before, so that you are informed before the session. All right. And with that, guys, that is it from my side. So like I said, I hope you guys learned something new today. So with that, guys, I hope oh, right, one more thing, guys. You can also, if you want to get notifications on YouTube, please subscribe to our channel and click on the bell icon, which is right next to it, so that you don't miss any on the live updates and any of the videos that we'll be uploading on AWS in the further time. All right. So with that, have a nice day ahead, guys. Good luck and goodbye.
Hey guys, if you're wondering how to deploy and monitor your application without worrying about underlying infrastructure while maintaining high availability, you have landed at the right place. I'm Archana from Edureka, and I welcome you to this session on Elastic Beanstalk, a web application hosting platform offered by Amazon. So without any delay, let me give you a brief overview of what we will be discussing today. Firstly, we will see what Elastic Beanstalk exactly is, and then we'll discuss certain salient features of Elastic Beanstalk. Moving on, we'll try to understand Elastic Beanstalk a little deeper by taking a look at its components and then at its architecture. And finally, we'll try to deploy an application on Elastic Beanstalk for practical understanding of the concept. So let's get started. What is Elastic Beanstalk? If I have to define Elastic Beanstalk in Amazon terminology, then it is a platform as a service where you can deploy your application which you might have developed with programming languages like Java, .NET, PHP, Node.js, and many others on familiar servers such as Apache, Nginx, Passenger, and Tomcat. The definition which I just mentioned seems to have a lot of technical terms, isn't it? Well, let's try to figure out what Elastic Beanstalk is in simple terms. Alright, let's say you need to build a computer tonight. Well, you have two ways to go at it. First, you can go to a computer warehouse. Computer warehouse is a place where you have different components of computer laid out in front of you. Like you have CPU, motherboards, router, disk drive, modems, and many other components. You can choose whichever component you need and assemble them and form a brand new computer. This is similar to a situation where you try to deploy an application without using Elastic Beanstalk. When you try to develop an application by yourself, you'll have a list of tasks which you need to do. Like you might have to decide on how powerful you want your EC2 instance to be. Then you have to choose a suitable storage and infrastructure stack for your application. You might have to install separate softwares for monitoring and security purposes as well. Moving on to option B, you can always visit an electronic retail store which has pre-configured computers laid out in front of you. Let's say you're a graphic designer and you want a computer which has a modern graphical user interface installed in it. All you have to do is specify this requirement to a salesperson and walk out with a computer of your choice. Well, I personally prefer this option. This is similar to the situation where you're trying to deploy an application using Elastic Beanstalk. When you use Elastic Beanstalk to develop your application, all you have to do is concentrate on your code. Rest of the tasks like installing EC2 instances, auto-scaling groups, maintaining security and monitoring, etc. is done by Elastic Beanstalk. That is the beauty of Elastic Beanstalk. So let's go back and take a look at definition again and see if we'll understand it this time. Well, Elastic Beanstalk is a platform as a service where developers just have to upload their application. Load balancing, auto-scaling, and application health monitoring are all handled automatically by Elastic Beanstalk. Now let's try to understand how Elastic Beanstalk as a platform as a service is beneficial to an app developer. I'm sure most of you know what platform as a service is, but let's try to refresh what we know. Platform as a service is a cloud computing service which provides you a platform where you can deploy and host your application. Elastic Beanstalk makes the process of app development much more fun and less complex, and I have 5 points to prove that to you. Firstly, it offers quicker deployment. Suppose you're developing an app by yourself, then you'll have to do a lot of tasks by yourself. Like you might have to decide on EC2 instance, choose a suitable storage and infrastructure stock, as well as install auto-scaling groups as well, and then you might have to install separate softwares for monitoring and security purposes. Well, this will take quite a lot of time. But if you have used platform as a service to develop your app, then all you have to do is develop a proper code for your application. Rest will be handled by platform as a service or Elastic Beanstalk in this case, which makes the entire process of app development much more faster. Secondly, Elastic Beanstalk simplifies entire app development process. Like I said, all developers have to do is concentrate on developing a code for their application. Rest, like monitoring servers, storage, network, etc., and managing virtualization, operating system databases is done by Elastic Beanstalk, which simplifies the entire process for a developer. Using platform as a service, to deploy application makes entire app development process more cost effective. If you're trying to deploy an app by yourself, then you might have to install separate softwares for monitoring and security purposes, and I'm sure for that you'll have to pay a lot of money, extra money. But if you're using an Elastic Beanstalk to deploy your application, it will provide you all this additional softwares as a package, and you can avoid paying unnecessary operating costs. Also, Elastic Beanstalk offers multi-tenant architecture. By that I mean it makes it easy for the users to share their application on different devices, and that too with high security. When I say high security, Platform as a Service will provide you a detailed report regarding your application usage, different people or users who are trying to access your application as well. With this information, you can be sure that your application is not under any cyber threat. And finally, Platform as a Service provides you an option where you can know if the user who is using your application is getting a better experience out of it or not. With Platform as a Service, you can collect feedback at different stages of your app development, like during development stage, like testing stage, production stage, design stage. By doing so, you'll have a report regarding how your application is performing at every level, and you can make improvements if needed. So this is how Platform as a Service like AR and Elastic Beanstalk makes it easy for developer to develop an all-around perfect app. Guys, you'll be able to relate to this point when we try to deploy an application using Elastic Beanstalk in the later part of the session. You will understand how Elastic Beanstalk is beneficial to our app developer. In market, there are quite a lot of application hosting platforms which are providing platform as a service. Let's have a look at few of them. First, we have something called OpenShift. It is a web hosting platform offered by Red Hat. Then you have Google App Engine, which we all know. A Scalingo, it is a platform as a service where you can deploy your application in just 2 minutes. Apparently, it will provide you a production-ready environment where all you have to do is deploy your application code. Then you have Python Anywhere. It is an online integrated development platform and web hosting service as well, but based on Python language. Then you have Elastic Beanstalk offered by Amazon. Moving on, we have Azure App Services by Microsoft and many others. But today, our main focus will be on Elastic Beanstalk, which is a web hosting platform offered by Amazon. Now that you have basic understanding of Elastic Beanstalk, let's go ahead and take a look at few of its features. Mostly, all these features are similar to the ones which we discussed earlier. Like Elastic Beanstalk makes an app development process more faster and simpler for developer. Moreover, all developer has to do is concentrate on developing code. Rest of the configuration details and managing and monitoring details will be handled by Elastic Beanstalk. Also, Elastic Beanstalk automatically scales up your AWS resources which have been assigned to your application by Elastic Beanstalk based on your application specific needs. But there is one feature which is specific to Elastic Beanstalk. Suppose you have deployed an application using Elastic Beanstalk, but now you want to make changes to the configurations which have been already assigned to your application by Elastic Beanstalk. Though Beanstalk is a platform as a service, it provides you with an option where you can change the pre-assigned configurations, like you do in infrastructure as a service. Well, if you remember, if you're trying to use infrastructure as a service to deploy your application, you will have full control over AWS resources. Similarly, Beanstalk also provides you with full control over your AWS resources, and you can have access to the underlying resources at any time. Now, let's try to understand Elastic Beanstalk a little deeper. First, we'll be discussing a few components of Elastic Beanstalk, then we'll have a look at its architecture. Let's see what we have here first. We have something called application. Suppose you have decided to do a project. So what you do, you go ahead and create a separate folder on your personal computer which is dedicated to your project. Let's say your project needs Apache server, SQL database, and a platforming software like Eclipse. So you install all these softwares and store them in the folder which is dedicated to your project. So that will be easy for you to access whenever you need all the softwares. Similarly, when you try to deploy an application on Elastic Beanstalk, Beanstalk will create a separate folder which is dedicated to your application. And in AWS terms, this folder is what we call an application. If I have to define folder or application in technical terms, then it is a collection of different components like environments, your application versions, and environment configuration. Let's try to understand each of these components one by one. We have something called application version. Suppose you have written a code, stored it in a file, and deployed this code on Elastic Beanstalk, and your application has been successfully launched. But now you want to make certain changes to the code. So what you do? You go ahead, open the file, make changes to it, save it, and then again deploy it on Elastic Beanstalk. Elastic Beanstalk again successfully launches your application. So you have two versions of your application now. It's just a copy of your application code, but with different changes. And Elastic Beanstalk will provide you with an option where you can upload different versions of your application without even deleting the previous ones. Then we have something called environment. Environment is a place where you actually run your application. When you try to launch an Elastic Beanstalk environment, Beanstalk starts assigning various AWS resources like EC2 instances, auto-scaling groups, load balancer, security groups to your application. The point which you have to remember is at a single point of time, environment can run only a single version of your application. But Elastic Beanstalk will provide you with an option where you can create multiple environments for your single application. Suppose I want a different environment for different stages of my app. Like I want an environment for development stage, one for production stage, and one for testing stage. I can go ahead and do that, create a different environment for different stages of my application. And suppose you have same version or different version of your application installed on all these environments, it's possible to run all these application versions at same time. I hope that was clear. Well, you'll understand them practically when we try to deploy an application in the later part of the session. Then we have something called environment tier. When you try to launch an Elastic Beanstalk environment, Elastic Beanstalk asks you to choose among two environment tiers, which are web server environment and then you have worker environment. If you want your application to handle HTTP requests, then you choose web server environment. And if you want your application to handle background tasks, that is where a worker environment comes into picture. I'll show which to choose, either web server or worker environment, and how to work with them when we'll try to deploy an application in the later part. And lastly, we have something called environment health. Based on how your application is running, Beanstalk reports the health of your web server environment, and it uses different colors to do so. First, gray indicates that your environment is currently being updated. Let's say you have installed one version and now you're trying to upload different version, but it's taking a lot of time. So that time it shows gray color. It means your environment is still under updating process. Then you have green, which means that your environment has passed the recent health check. Then you have yellow, which means that your environment has failed one or more checks, and red failed 3 or more checks. Moving on, let's try to understand the architecture of Elastic Beanstalk. Like I said earlier, when you try to launch an Elastic Beanstalk environment, Beanstalk asks you to choose among two different environment tiers. Firstly, we have web server environment. Web server environment usually handles HTTP requests from clients, and it has different components. Firstly, we have something called environment. You know what environment is? It's a place where we actually run your application, and Beanstalk provides you with an option where you can create multiple environments. And the main point is, at a point of time, this particular environment can run only one version of your application. Moving on, we have something called Elastic Load Balancer. Let's say your application is receiving a lot of requests. So what Elastic Load Balancer does is, it distributes all this request among different EC2 instances so that all the requests are handled and no request is being denied. What actually happens is, when you launch an environment, a URL is created, and this URL in the form of CNAME is made to point Elastic Load Balancer. CNAME is nothing but an alternate name for your URL. So when your application receives request, all these requests are forwarded to Elastic Load Balancer, and this load balancer distributes these requests among EC2 instances of auto-scaling group. Then we have auto-scaling group. Well, if your web server is trying to handle a lot of traffic and it's having a scarcity of EC2 instances, then auto-scaling group automatically installs few EC2 instances. Similarly, if traffic is very low, then it automatically terminates underused EC2 instances. Then we have EC2 instance. So whenever you try to launch an Elastic Beanstalk environment, Beanstalk will assign your application with a suitable EC2 instance. But the software stack, like the operating system, the servers, and different softwares which are supposed to be installed on your instance are decided by a device called container type. For example, let's say my environment has an Apache Tomcat container. So what it does, it installs Amazon Linux operating system, Apache web server, and Tomcat software on my EC2 instance. Similarly, depending on your application requirements, it installs different software stack on your EC2 instances. Then we have a software component called Host Manager, which runs on every EC2 instance that has been assigned to your application. This Host Manager is responsible for various tasks. Firstly, it will provide you a detailed report regarding performance of your application. Then it provides instant level events. It monitors your application log files as well, and it monitors your application server. You can view all these metrics, log files, and create various alarms on CloudWatch monitoring dashboard. Then you have security groups. Security group is like a firewall to your instance. Not anybody can access your instance. It's just for the security purposes. So Elastic Beanstalk has a default security group which allows client to access your application using port 80. You can define more security groups if you need. And then Elastic Beanstalk also provides you with an option where you can define a security group for your database for security purposes. Moving on, we have something called worker environment. First question that comes to our mind is, what is worker? Well, suppose your web server has received a request from client, but on the way, while it's trying to process the request, it has come across tasks which are consuming a lot of resources and taking a lot of time. Because of which, it's quite possible that your web server might deny other requests. So what it does, it forwards these requests to something called worker. This worker handles all these tasks on behalf of web server. So basically, worker is a process that handles background tasks which are time intensive and resource intensive. And in addition, if you want, you can use worker to send email notifications, to generate metric reports, and clean up databases when needed. Let's try to understand why we need worker with the help of use case. So I have a client. He has made a request to web server, and the web server has accepted the request, and it starts processing the request. But while it's processing the request, it comes across tasks which are taking a lot of time. Meanwhile, this client has requested or sent another request to web server. Since web server is still processing the first request, it denies second request. So what is the result of this is, the performance and the number of requests accepted by your web server will drastically decrease. Alternatively, let's say a client has made a request and your web server has accepted it and it starts processing the request. And again, it comes across tasks which are taking a lot of time. This time what it does, it transfers or it passes all these tasks to worker environment. And this worker environment will handle all these tasks. And request 1 is successfully completed. Meanwhile, if it receives a second request, since it has completed processing request 1, it will accept request 2. I hope the scenario was clear. Well, all we are doing by installing worker environment is we are avoiding spending a lot of time on single request here. Now you know what web server environment is and worker environment is, and why do we need worker environment. But there has to be some way so that this web server environment can pass on this task to worker environment. Let's see how. So you have your web server environment. It has received a request, and while processing, it has encountered tasks which are taking a lot of time. So what it does, it creates an SQS message. SQS is a simple queue service offered by Amazon. And this message is then put into SQS queue. And the different requests are arranged based on priority in the SQS queue. Meanwhile, when you're trying to install worker environment, Elastic Beanstalk installs something called daemon. What this daemon does, it pulls SQS message from SQS queue. And then it sends this task to web application which is running on worker environment. As a result or as a response, this Beanstalk application handles all this tasks and responds with an HTTP response option. So this is how the entire process of handling tasks, transferring and then handling tasks goes on. So you have a client. He has made a request to web server, but the web server is encountered with tasks which are time consuming and resource consuming. So it passes this request to SQS queue. And when you try to install worker environment, there's a daemon which pulls out all these messages or tasks from your SQS queue. And then this daemon sends all these tasks to your application. Application resolves all these tasks and then it responds with a HTTP response option. So this is how your two applications communicate. I think that was a lot of theory. Don't worry, we have arrived at the fun part of the session where we'll be trying to deploy an application using Elastic Beanstalk. Here, by doing or by creating an application on Elastic Beanstalk practically, you'll understand different concepts, its architecture, and different environment ties and all this. So let's go ahead. So this is my AWS Management Console. And if you want to take a look at all the services, then you have all the services here. But we're mainly concerned with Elastic Beanstalk, which I've recently used. So it shows the all recently used resources or services here. So I'm going to choose that Elastic Beanstalk. And this is my Beanstalk console. If you're trying to deploy an application for first time, this is the page where you land. When we scroll down, it says that I can deploy an application in 3 easy steps. All you have to do is select a platform of my choice, then upload a application code if I have one, or use a sample application code and then run it. Let's see if it's as easy as it says here. So go ahead and click on create new application option here. It'll ask you for application name and description. I'm going to name my application as Tomcat app, then description as my new web app. And then I'm going to click on this create option. See, when I try to create an application, it has created a separate folder which is dedicated to my application. And in that folder, we have different components. As you can see here, I have my environment, then I have application versions. And if I've saved any configuration, it will show all the saved configurations here. Now let's go ahead and create an environment. On the right side, you see an actions option and you click on that, you get different choices. You can just select create environment here. So again, it's asking you to choose among two different web environment tiers. You have web server environment and worker environment. In web server environment, your application handles HTTP requests from clients. Then you have worker environment, where your application will process background tasks like time-intensive and resource-consuming tasks. In this demo, I'm going to work only with web server environment. You can go ahead, explore, and create worker environment once you understand how to deploy an application on Elastic Beanstalk. So I'm going to click on the select option here. It will take me to a page where I'll have to give a domain name, or in technical terms, a URL to my application. You can give any URL of your choice and see if it's available. So let's say my Tom app, and let's see if it's available. It says the domain name is available. Then description, I'm going to give it the same as before. So my new web app. Then when I scroll down, it asks me for a platform of my choice. There are different options. You have Go, then you have .NET, Java, Ruby, PHP, Node.js, Python, Tomcat. And if you're trying to deploy an application on the platform which is not here, you can configure your own platform and deploy it on Elastic Beanstalk. It provides you an option. Here you can see there's a custom platform here. So I'm going to choose Tomcat platform for my application. And since I'm not any kind of developer, I'm just going to go ahead and use the sample application provided by Amazon. But if you have any application code, if you have created or developed some code, you can store that in a file and upload here. It says you can upload your code. Then you have a zip. You need to convert your file to zip or WAR file and then upload it here. So I'm going to just select sample application and then click on create environment here. So it's going to take a while for Elastic Beanstalk to launch my environment. Though it's not as much time as it would have taken me to develop entire application by myself. While Elastic Beanstalk is trying to launch environment, let's discuss some points. In the earlier part of the session, we discussed some benefits of Elastic Beanstalk. Firstly, I said that it fastens your process of developing an entire app. So it's true, doesn't it? All I did was select the platform of my choice. Rest is done by Elastic Beanstalk itself. So thereby it's saving a lot of time. Similarly, it simplifies the process of app development. Again, all I did was select a platform of my choice, like installing EC2 instances, security groups, auto-scaling groups, and assigning IP addresses. Rest is done by Elastic Beanstalk. I even mentioned a point where I said that it will provide Elastic Beanstalk provides you with an option where you can change the pre-assigned configuration. We'll explore that once the environment is created. Let's go ahead and see what Elastic Beanstalk is doing. It says that it has created a storage for my environment where S3 bucket, so that all my files where I have my application code are stored there. Then it has created a security group as well, an Elastic IP address. Then it says it's launching an EC2 instance. So you see, it's as easy as that. All you have to do is select a platform of your choice. Rest is handled by Elastic Beanstalk. And later on, if you're not satisfied, if you want to change some configuration, you can go ahead and do that. Here, look at this. This is the IP address or domain name which I assigned to my app. It says new instance has been added. And in addition, it's showing each task while it's doing. Isn't that cool? You'll know what your environment is currently doing. So it's still taking a while. So it says it has installed and added instance to my application and my environment has been successfully launched. It has finished almost all the tasks. It should have taken to environment page now. So this is my environment page, or you can say a dashboard. First, you have environment health here. It says green. It means that my environment has successfully passed the health check. Then it shows the sample version of your application. Since I've used the sample application, it's saying sample application here. Since I've chosen Tomcat as my platform, it has installed suitable infrastructure stack like Amazon Linux, and you have Java 8 programming language. Let's go ahead and explore this page. First, we have something called configurations here. Like I said, though it is a platform as a service, it provides you with an option where you can change configuration. So you will have full control of your resources. First, we have something called instances here. When I click on modify option, you can see that Elastic Beanstalk has assigned micro instance to my application. If I want, I can go ahead and change it to different instance based on my application requirement. Scrolling down, I have CloudWatch monitoring. If I want detailed monitoring, then I can go for 1 minute. If I want basic monitoring and not so detailed monitoring, then I can choose 5 minutes here. Then I have an option of assigning storage to my application as well. It says we have magnetic storage, general purpose, and provisioned IOPS as well. When we scroll down again, we see different security groups. I can just click on that and the security group will be added to my application. So once you've made the changes, you can click on apply option here. Though I haven't made any changes, I'm just going to click here. So now Elastic Beanstalk is trying to update my environment. So it's showing gray color here. If you recollect, I mentioned during the earlier part that gray indicates my environment is being updated. Okay, let's go back to configurations. We did have a look at instances. Then you have something called capacity. Apparently, Elastic Beanstalk is assigned a single instance to my application. If I want, I can go ahead and change to auto-scaling groups. You have an option called load balancer. You can click on that here. And you can set the minimum and maximum number of instances that your auto-scaling group can install as well. Then if you have chosen a load balancer option earlier, then a load balancer would have been enabled here. Then we have monitoring details, which provides you with two options, enhanced monitoring and basic monitoring. And when we scroll down, you can see a streaming to CloudWatch logs option here. So if you want your log files, you can view them on CloudWatch dashboard as well. You can set the retention period according to your choice. And suppose you want your application for some private purpose, then you can generate a private VPC for your application. Similarly, you can add or decrease the amount of storage as well. So by explaining all this, what I want to say is your hands are not tied. You can make changes to configurations if you want. Then we have logs option. If you want to have a look at the last 10 lines of your log files, then you have an option. It says last 100 lines. Then if you want full log files, then you click on that. It will provide you a file in download format. You can just download it. Then we have health option here, where it provides the health of your AWS resources. Basically, it shows EC2 instance here. It says it's been 7 minutes or 6 minutes since my EC2 instance has been installed. Then you have monitoring, where it shows different monitoring details like CPU utilization, network in, network out. If you want, you can go ahead and create an alarm with alarm option here. Suppose you want the notification to be sent to you when the CPU utilization or when the number of EC2 instances are scarce in your auto-scaling group. Then you have events here. Events basically are nothing but it's a list of things which has happened since you started launching an environment. When I go down, it says, we have seen earlier on the black screen, the same things are applied here. So it says create environment is starting. Then we saw that EC2 instance has been installed, security groups, elastic IP address. So basically it shows all the events that has happened from the time Elastic Beanstalk has started to launch your environment until the time you terminated the environment. So that's it. Then you have tag files. You can assign different key values as well. Let's go back. This is a sample application which I've tried to use. Now let me try to upload and deploy a new application version here. Okay, I'm gonna go to documentation here. I'm interested with Elastic Beanstalk. I'm gonna select on that and then developer guide. Click on getting started here. When you scroll down and deploy a new application version here, based on your sample application, you have different versions of your application. Since I've selected a Tomcat as my platform, I have a Tomcat zip file here. I have already downloaded that. So I'm just gonna upload the file there. So let's go back and it says upload and deploy. But let's go back to our folder. Then there's an application versions option here. So it gives you deploy and upload option separately here. I'm just gonna upload first, then we'll deploy it. Version label, new version, and upload the file. I have it here, zip file. I'm just going to attach the file and then click on upload option. The new version of my application has been uploaded, but it's not been deployed yet. So when I go back here, you can see that I can still see the same version which was there before. Now let's go back and deploy it. Okay, I'm going to select this and then I'm going to click on deploy option and select deploy here. Let's go back to environment and check. So my environment is being updated. So again, the gray color here. Once it's updated, it will show the new version name here. It is uploaded. So as you can see, it's showing the version name of my new version, application version. Like I said earlier, both my application versions are there. I haven't deleted any. You don't have to delete your application versions when you create a new one. Similarly, you can upload multiple versions of your application. Going back, actions option. Then you have load configuration, which will definitely load your configuration. Then you have save. You can save this configuration. Suppose you want to create an application with same configurations. Again, you don't have to start from the beginning, from creating application, environment, all that. You can just save the configuration and use for the other application or other environment of your application. Then you can clone your environment as well, rebuild the entire environment and terminate as well. So here I have saved configuration. If I have saved this configuration, the configuration have been listed here, and like that configuration I can use when I'm creating a new environment. Okay, just let's see if I've explored all the options. Environment. Well, I forgot to show you one most important thing. When I click on this URL, it takes me to a page where it shows that my application has been successfully installed. Well, that's it. So now you know how to deploy an application using Elastic Beanstalk. Though I have used the sample application here, you can go ahead and upload a code of yours if you have any and try it out. Well, all the options here seems to be user friendly, so you will know what to do. It seems to be easier process. You will understand it better when you try to deploy an application by yourself. So this is it, guys. I hope the session was informative and fun. If you have any doubts, you can post them in the comment section below. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
Hey guys, this is Hemant from Edureka. Today in this session we'll be talking about cloud security. Without making any further ado, let's move on to today's agenda to understand what all will be covered in today's session. So we'll start off this session by discussing the why and what of cloud security. After that, we'll be seeing how we can choose between a public, a private, and a hybrid cloud. After that, we'll see whether cloud security is really a concern among companies who are planning to make a move onto the cloud. So once you have established that cloud security is really important, we'll see how secure should you make your application. After that, we'll be looking into the process of troubleshooting a threat in the cloud. After that, we'll be implementing that process in AWS. So guys, this is our agenda for today. Are we clear with it? Okay, I'm getting confirmations. So Dinesh, Shivani, Jason, Bibek has given me a confirmation. Okay guys, since most of you are clear, let's move on to the first topic of today's session, that why cloud security is important. So let's take an example here and talk of three very popular companies, LinkedIn, Sony and iCloud. So LinkedIn in 2012 experienced a cyber attack wherein 6.5 million usernames and passwords were made public by the hackers. After that, Sony experienced the most aggressive cyber attack in history, wherein their highly confidential files, like their financials, their upcoming movie projects, were made public by the hackers, right? And this made a huge impact on the business front of Sony. iCloud, which is a service from Apple, also experienced a cyber attack wherein personal or private photos of users were made public by the hackers. Right? So guys, now in all these three companies, you can see there's a breach in security which needs to be addressed, right? So cloud security has to be addressed. It needs to be there in the cloud computing world. So since now we've established that cloud security is really important, let's move on to understand what cloud security actually is. So what is cloud security? So it is a use of latest technologies and techniques in programming to secure your application which is hosted on the cloud, or the data which is hosted on the cloud, and the infrastructure which is associated with the cloud computing. Right? And the other part of this is that whatever security techniques or whatever techniques or technology that you're using to secure your application should be updated as frequently as possible, because every day new threats are coming up, right? Every day there are new workarounds to problems, right? And you should be able to tackle these problems or these workarounds, and hence you should upgrade your security as frequently as possible, right? Moving ahead, let's understand how we can choose between a public, a private, and a hybrid cloud. So we've understood that what cloud security actually is. Now let's talk in terms of security and understand how we can choose between a public, a private, and a hybrid cloud. So if you were to choose between these three infrastructures, what should be our basis of judging which cloud we should choose, right? So you would opt for a private cloud when you have highly confidential files that you want to store on the cloud platform, right? Now there are two stories, or there are two ways of thinking a private infrastructure. You can either opt for private servers or private infrastructure on your own premises, or you can look up for servers, dedicated servers by your cloud provider, right? So that all comes under the private infrastructure. Then we have the public cloud infrastructure. In public cloud infrastructure, you would basically use websites that are public facing. So say if you have a products page where you have application which can be downloaded by the public, so that can be hosted on the public cloud because there is nothing that has to be secret over there, right? So things like websites, things like data that is not confidential and you don't mind public seeing it can be hosted on your public cloud. The third infrastructure is the most important infrastructure, which is the hybrid infrastructure, and this is the setup that most companies go for, right? So what if there's a use case wherein you have private files, highly confidential files, and a website as well, right? So if you have this kind of use case, you might go for a hybrid infrastructure, which is kind of best of both worlds. You get the security or the comfort of the private infrastructure and the cost effectiveness of the public cloud as well, right? So your hybrid cloud is basically, if you want your highly confidential be stored on your own premises and your website be hosted on your public cloud, this infrastructure would be hybrid cloud infrastructure. So basically you would choose a private cloud if you have highly confidential files. If you choose a public cloud if you have files that are not that important or files that you don't mind people seeing, and you would choose a hybrid cloud infrastructure if you want best of both worlds, right? So this addresses how we can choose between a public, private, and hybrid cloud. Moving on, let's understand whether cloud security is really a concern. So we have discussed that why cloud security is important. We've discussed what is cloud security, right? Now let's talk about whether this really makes sense, right? So if we say that cloud security is really important and there's no one who is actually thinking about it, there's no point, right? So let's see if companies who are making a move to the cloud actually think about cloud security. So here's a Gartner research on companies who are making a plan to move to the cloud or who has not moved to the cloud yet, right? So what are their concerns? Why are not they doing so? So the topmost reason listed by these companies was security and privacy concerns, right? So as you can see, these companies who want to make a move to the cloud are also worried about their security on the cloud infrastructure. And this makes it clear that cloud security is actually very important, right? Now we've understood that cloud security is really important. We have understood that companies are looking for cloud security, are actually following the practices for cloud security. But now, how secure should you make your application, right? What is the extent to which you should make your application secure? So let us start with this line. So it is said that cloud security is a mixture of art and science, right? Why? Let's see that. So it's a science because obviously you have to come up with new technologies and new techniques to protect your data, to protect your application, right? So it's a science because you have to be prepared with the technical part. But it is art as well. Why? Because you should create your techniques or you should create your technologies in such a way that your user experience is not hindered. Let me give you guys an example. Suppose you make an application, right? And for making it secure, you think, okay, after every 3 or 4 minutes, I'll ask the user for a password, right? From the security point of view, it seems okay, but from the user's point of view, it is actually hindering his user experience, right? So you should have that artist in you that you should understand when to stop or till where should you extend your security techniques. And also you should be creative as to what security techniques can be implemented so that the user experience is not hindered. For example, there is a two-step authentication you get that when you're logging into your Gmail account, right? So if you know your password, that is not enough. You should have an OTP as well to log into your Gmail account, right? So this might be hindering with user experience to some extent, but it is making your application secure as well, right? So you should have a balance between your science and the art part that you're applying on cloud security. Moving on, let's now discuss the process of troubleshooting a threat in the cloud. So let's take an example here. So like you're using Facebook, right? And you get a random message from some person saying there is some kind of story, like you usually get that while you're using Facebook, right? That such and such thing happened and click here to know more, right? You get that similar kind of message here. And by mistake, you actually click on that link. You didn't know that it's a spam and you click on that link. Now what happens is all the users that are there or all your friends on the Facebook chat gets that message, right? And they get furious as to why this kind of spam message is there in their inbox, right? And you get scared. Now you get angry as well and you have to bring your frustration out on Facebook. So you contact Facebook and you get to know that they already know the problem and they're already working on it and they're near to their solution. Now, how did they come to know that there is this kind of problem and needs to be solved, right? So basically cloud security is done in three stages. So the identification process or the threat identification process is done in three stages. The first stage is monitoring data. So you have AI algorithms which know what a normal system behavior is. And any deviation from this normal system behavior creates an alarm. And this alarm is then monitored by the cloud experts or the cloud security experts sitting over there. And if there's a threat, they see there's a threat, they go to the next step, which is gaining visibility, right? So you should understand what caused that problem, right? And or who caused that problem precisely. So your cloud security experts look for tools which give them the ability to look into the data and find or pinpoint that statement or pinpoint that event which caused this problem, right? So that is done using gaining visibility stage. And once we have established, okay, so this is the problem, then comes stage 3, which is managing access. So what this basically will do is it will give you a list of users. In case we are tracking the who, it'll give you a list of users who have access and we will pinpoint the user who did that, right? And that user can be wiped out of the system using the managing access stage, right? So these are the stages which are involved in cloud security. Now, if we were to implement these stages in AWS, how would we do that? Let's see that. So the first stage was monitoring data, right? So if you have an application in AWS and you are experiencing this same kind of thing, what will you do for monitoring data? So you have a service in AWS called AWS CloudWatch. Now what is AWS CloudWatch? So basically it's a cloud monitoring tool. So you can monitor your EC2 and your other AWS resources on CloudWatch. How you can monitor them? You can monitor the network in, network out of your resource, and you can also monitor the traffic which is coming onto your instance, right? You can also create alarms on your CloudWatch. So if there's deviation from normal system behavior, like I said, so it'll create an alarm for you. It'll escalate the event and alert you about that thing so that you can go on and see what that problem actually is, right? So this is cloud, the monitoring tool, right? So this was about AWS CloudWatch. Let me give you a quick demo of how the AWS CloudWatch dashboard actually looks like. Okay guys, so this is your AWS dashboard. So now for accessing CloudWatch, you can go under the management tools. Here is CloudWatch. You'll click on CloudWatch. Now over here you can monitor anything, right? You'll go to metrics and you can see there are 3 metrics over here. You can monitor your EBS, you can monitor your EC2, you can monitor your S3, right? Now say suppose I want to monitor my EC2. So as you can see, so I have 2 instances running in my EC2. One is called for batch instance and the other is called WPS instance, right? Now these are all the metrics which are there. So I can check metrics for my WPS instance for network in, I can check the disk read ops. So let me select the network out metric, and there'll be a graph over here. So I can see this graph, and as you can see, between 6 o'clock and 6:30 I experienced a surge in my traffic, right? So basically this is how you monitor your instance in CloudWatch, and you have all these default metrics to check how your instance is doing in your AWS, right? So this is what CloudWatch is. You can also set alarms here, right? So if you go to alarms, click on create alarm, you'll go to EC2, and you can select your metric from over here. Now I've selected discrete bytes over here. Now once I do that, it'll ask me if there's a time range to which I want to monitor that instance, right? Okay, let's not set any time range. Let's click on next. So when you click next, you will be prompted with this page. So you can set your alarm name, you can set your alarm description here, and then you can specify that for what read write number you should get this alarm for, right? So you'll be setting that over here. After that, you'll go to actions. So once an alarm is triggered, where should that alarm go? Who should that alarm go to, right? So you can set it over here. Now, whenever the state is alarm, right, what should we do? So when the state is alarm, you can send your notification to your SNS topic. Now what is SNS? So basically it's a notification service. We'll be discussing what SNS is in the next session. Don't worry if you don't understand. So basically for now, what you can understand is that SNS is a protocol wherein you set, if you get a notification, what to do with that notification or whom to send to that notification, right? So if there's a topic called notify me in SNS. So in notify me, I have configured an email address that is my email address, that whenever a notification comes to the SNS service, or the notify me topic to be precise, it sends an email to me, right, with that message. So I'll get a message with this alarm that such and such thing that has happened in CloudWatch. Now you do whatever is required. The other thing that you can do over here is in the same SNS topic, you can also configure a Lambda function to be executed, right? Now what that Lambda function will do, so say suppose I configure the metric to be of CPU usage, right? And I say whenever the 40% metric is crossed, create an alarm, or like go to an alarm state, and it notifies the SNS notify me topic about this. In the notify me topic, I can configure a Lambda function to clear all the background processes in that EC2 instance, right? So if I do that, the CPU usage will automatically come down, right? So this becomes a use case that you want to launch a Lambda function whenever your CPU usage goes beyond 40%, right? And hence, this is the way you would do it. So this was about CloudWatch. There's nothing much to it. You create alarms and you monitor metrics, right? Moving ahead, let's move on to the second process, which is gaining visibility. So for gaining visibility, basically you have to track your whatever activity is happening in your AWS account. So there's a service in AWS called CloudTrail, right? So the CloudTrail service is basically a logging service wherein each and every log to each and every API call is made. Now, how is it useful? Let's talk about the security perspective, right? So your hacker got access to your system, so you should know how he got access to your system. So if you have a time frame, say he got access to your system, or you started to face the problem, say around 4 o'clock, right? So you can set the time between 2 o'clock and whatever the time is right now and monitor what all has been going around. And hence you can identify the place where that hacker got access to your system, right? Now this is the part where you'll get to know who that person actually is, or you can isolate the problem or which caused that. So if you take a Q from our Facebook example, over here you can actually pinpoint who is responsible for those spam messages, because you'll all have those logs, right? You'll see the origin of those messages. Now, once you've done that, the next step is managing this guy out of the system, or wiping this guy out of the system. But before that, let me show you guys how CloudTrail actually looks like. So let's go back to our AWS dashboard and go to our CloudTrail service. So again, under the management tools, you have the CloudTrail service. You'll click on the CloudTrail service and you will reach this dashboard. All right, so here you have the logs. So as you can see, you can set the time range here, but I'm not doing that. I'm just showing you the logs. So even for logging into my console, it is showing me that I've logged into my console at this time on this date, right? So every event is logged, guys. Every event that is happening on your AWS console is being logged. So let's talk about the S3 bucket. So somebody deleted a bucket and that has again been logged, right? So it happened at 7:38 p.m. on 28th of March 2017, right? So any activity, any kind of activity which happens in AWS will be logged over here. Okay guys, so this was about CloudTrail. So let's go back to our slide and move ahead in today's session. So like I said, so now you've identified who is responsible for your problem, right? So now the next step is managing access, right? So now you should be able to throw that person or remove that person from the system. So most of the times what happens is, like if you take our Facebook use case, so basically there was a user who triggered that problem, right? So the two things that you have to do is, first of all, you have to remove that spam from your system. So you've got to know where it originated, so now you start wiping it. After that, you have to debar that user from doing it again, right? So from the source, you'll get to know who that user is. Now, using managing access, you will actually get access to do all that, right? So if you talk about AWS, this service is called AWS IAM. So what AWS IAM does is, it basically authenticates that particular service. Now you are a root user, right? So you can do anything. But what if you have employees, and obviously all employees will not have all the rights, right? Now what if you want to give granular permissions to your employees? Now for like in our example, what if one specific employee is capable to track down this problem, right? Or track down what has to be done. So you can give that particular person the rights. How? Using IAM, right? So IAM is used to provide granular permissions. It actually secures your access to the EC2 instances by giving you a private file, and also it is free to use, right? So let's see how IAM is used. So let me go back to my AWS console. Okay guys, so this is my AWS dashboard. I'll go to the security, identity and compliance domain and I'll click on IAM, right? Now over here I'll click on roles. Now I can see all the roles which are there in my IAM, right? So since I would have identified which role is creating a problem, so I'll go to that role. So for example, I have a problem in say AWS Elastic Beanstalk EC2 role, right? I'll click on this. Now once I click, I will be getting this screen. So now I can see the permissions, the trust relationships, the access advice and the revoke sessions, right? So I'll go to revoke sessions and I'll click on revoke active sessions, and hence I'll be able to wipe out that user from accessing my AWS resources, right? So this is how you use IAM, guys. Now one more thing that you can do over here is you'll go back to your dashboards, go to roles. Now like I told you guys, you can actually create a role for a person who will be able to access restricted things on your AWS account, right? So let me quickly show you how you can do that. So you'll click on create new role and you'll give your role some name. So let's give it hello over here, right? Click on next step, go to role for identity provider access, right? And now you can select how that user of yours will be accessing your AWS account, right? So allow users from Amazon Cognito, Amazon, Facebook, Google ID. All right, so let's select this. Now let us select Facebook and let's give it some random application ID, right? So anyways, not going to create this role. I'm just telling you guys how to do it, right? So basically you get your application ID by Facebook. Over there you'll be, since you are using Facebook to authenticate that guy to your AWS account, you'll get an application ID by going on to graph.facebook.com. You can do all of that over there. Okay, so that is not the concern. You'll enter the application ID and click on next step, right? So you'll get that policy document. So whatever you configured in your text boxes has actually been created in a JSON file, right? So you don't have to edit anything over here. Click on next step. Now you have to attach a policy. Now what is the policy? So policy is basically what all permissions you want to grant that user. right? So if you want to grant him the execution role for Lambda, you can do that. You can grant him the S3 execution role, right? So whatever policy that you create, you can actually create a policy in your IAM, right? I'm not going much in details of this because all of this is covered in your IAM session, but I'm showing you guys because as I just told you guys how this can be done. So let me show you how it can be done, right? So you'll select whatever policy you want and click on next step and review it and create that role. This is it, guys, right? So you can actually select a policy, whatever policy you want that role to have, and hence, so policy is basically a permission that you want that role to have. So if he gets a permission to just review your instances, he'll be only able to review your instances. Okay, one more thing I want to make clear is that you don't have to give your security credentials to that guy anymore, because now you'll be specifying that user will be able to connect to Facebook. Okay, so also you have a part here wherein you can specify what specific user can access it, right? So I can type in my name here, and if I'm being logged in through Facebook, if my username is Hemant Sharma, only then I'll be able to connect to my AWS account, right? Now this is ID, right? I can also set the locale parameter, right? So ID I think is fine, wherein you will be adding the ID of the guy whom you want this AWS account be accessed by, right? So you all have Facebook IDs, right? So you all have to just punch in your Facebook IDs over here, click on next step, and then you'll be able to access this AWS account if I create this role right now with the policies that I'll be attaching to your role, right? So this is how you use IAM, guys. Let us go back to our session. Okay, so these are the three services, guys. So you have IAM, you have CloudTrail, and you have CloudWatch, using which you can control or you can actually see what is going on in your AWS account. All right, so guys, this brings us to the end of our session. Anything that you're not clear of, you can ask me right now. Okay, so Akriti is clear. So is Jason, Shivani is clear as well. Vivek, Matthew. Okay guys, so since most of you are giving me a go, let me wrap up today's session. So thank you for attending this session, guys. I hope you learned something new today. I have attached the assignments in your LMS, and I expect you guys to complete your assignments by the next session. Also, the practicals that we've done today, I want you to try them on your own. I didn't execute them to the fullest. That was because of the shortage of time, but you do that, right? If you have any problems, you can contact our support team, right? They're always at your disposal 24/7. All right, guys, so see you in the next session. Thank you for attending today's session. Goodbye.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!
Hey guys, this is Hemant from Edureka. Today in this session, we're going to discuss about the service AWS CloudFormation. So without wasting any more time, let's move on to today's agenda. So we'll start today's session by discussing why CloudFormation is actually needed in the first place. Once we're done with that, we'll move on to the what of what is CloudFormation actually. After that, we'll be discussing what things are needed to get started in the CloudFormation service. Now, among those things, you have a JSON document. So we'll be learning how to create a JSON document. So before that, we'll be seeing the structure of a JSON document. Once we learn the structure, we'll see how a JSON document actually looks like. So we'll see how a sample JSON document looks. And in the end, we'll be doing a demonstration. So in the demonstration, we'll be doing two demos. The first one will be a really simple one, and the other one will be a little advanced, right? So guys, this is our agenda for today. Are we clear with it? All right, so I'm getting confirmations. John says yes. Dinesh says yes. Dheera says yes. Parvati says all clear. All right, guys, since most of you are clear, let's move on to the first topic, that is why AWS CloudFormation. So why do we need CloudFormation? So for example, you have an application. Now, most of you guys know that and we have done this in the previous sessions as well, that we created an application, right? Now that application is actually dependent on a lot of AWS resources. Now, if we were to deploy and manage all these resources separately, it will take up a lot of time of yours, right? So to reduce that time or to manage all these resources, what if I told you you have a service? Yes, you got that right. So you have a service called AWS CloudFormation. So using AWS CloudFormation, you can manage and create and provision all these resources at a single place. Now, this is what CloudFormation does. But now, what is CloudFormation exactly? So a CloudFormation is basically a service which helps you model and set up your AWS resources so that you can spend more time on your application rather than setting up and provisioning these resources, right? So basically it's a tool using which you can create your applications quickly. Also, you can create templates in AWS CloudFormation. Now, how do you create templates? Basically, you would be using the CloudFormation designer. You'd be putting in all the resources that are needed. You would be defining the dependencies of these resources, and then you'll be saving this design as a template, right? Now, what will you do with this template? This template can be used to create as many copies as you want, right? Say, for example, you have a use case wherein you want your application in multiple regions for backup purposes, right? So if you want that, you won't be implementing or you won't be creating each and every resource one by one in each of the regions. What you can do is you will create it at one place in CloudFormation, have that template in your hand and deploy that template in the other regions as well, right? So what will this do? So first of all, your replication will be very precise, right? So there won't be any changes in the copies that you have made. Second of all, you'll be doing that quickly because you don't have to do the process all over again. You just have to click a button and that template will be provisioned or will be launched in that region. So this is what AWS CloudFormation is all about. It makes your life simpler by handling all the creation and the provisioning part, right? So this is what is AWS CloudFormation. Now, how do we get started in CloudFormation? Since it's a very useful service, how can you as a user use this service? So let's move on. So for using the CloudFormation service, first of all, you need a JSON script. Now, why do you need a JSON script? Because you'd be creating a template, right, in the CloudFormation designer. You'd be using the drag and drop option and filling in the AWS resources, right? Now, when you'll be doing that in the backend, it'll actually be creating a JSON script. Now, what you can do as a user is if you're good in JSON, you can create your own JSON script. Otherwise, you can use the CloudFormation designer to create a template. Now, for creating a template, like I said, you need a JSON script. Now, what is a JSON script then? So a JSON script is basically a JavaScript object notation file, which is an open standard format. That means it is human readable. So you can read it as well as the computer. So if you don't need the programming knowledge for this, what you as a user would be doing is you would be designing your template in the CloudFormation designer, and that will automatically create a JSON script. You can do it the other side as well. Like I said, you can create your own JSON script and feed it in the CloudFormation designer. So this is how CloudFormation works. This is how you'll be using AWS CloudFormation. But then how can you learn the JSON script? So it's very easy. So basically you have to follow a structure in the JSON document. What is this structure? So that structure is like this. You'll be creating the following fields. So the first field will be the AWS template format version. So this will basically contain version of your template. Next up is the description. So description is a text only file or is a text only field wherein you'll be describing your template in words, right? So if I'm a user and I want to know what your JSON does, without reading your JSON script from beginning to end, I can read the description in simple English and understand what your JSON script will do, right? Then you have the metadata. So metadata will basically contain the properties of your template. Then you have the parameters. So any values that you have to pass to the template will be included in the parameters. Next comes mappings. So mappings would basically include the dependencies between your AWS resources. Then comes conditions. So conditions are basically the conditions that you'll be giving to your template when the stack will be created or while the stack is upgraded. So if your stack is being created or your stack is being upgraded, these conditions will be looked onto. Then comes outputs. So whatever outputs your template will provide or your creation or stack will provide will come in the outputs header. Then you have the resources field. So resources field will basically include all the AWS resources that you want to include in your infrastructure, right? Now, if you look carefully, you actually will be only dealing with the resources part, right? Because you will just be populating in the resources and creating the dependencies, right? So basically you'd be populating the resources part, and that is what it was all about, the resources part, right? Now, this is theory. Now, how does a JSON document actually look like, right? A JSON document looks something like this. So like I said, you'd be working on the resources field, right? So you'd be including the resources field, and in that, say so this JSON document is all about, if you had noticed, it's about S3, right? So you are basically including an S3 bucket, and in the type you'd be specifying the type of service that will be including this bucket, right? Like in this example, a JSON document doesn't know what service you're talking about. So you'd specify the name of the bucket, and inside the braces you'll be specifying which service. So over here you'll be specifying the S3 service. Don't worry, I'll be showing you guys this JSON document in a moment, but before that you should understand how a JSON document is structured, and this is what we're doing right now. Now guys, this is the CloudFormation dashboard. Now you have to create a stack over here, right? And for the creation of a stack you require a template. So first we'll design a template and then we'll create a stack. So this is my CloudFormation designer. Let's go back to our slide and see what we actually have to do. So this is our first demonstration. Herein we'll be creating a S3 bucket from CloudFormation. So we'll be designing a template around that for first, and then we'll be deploying this code, right? So let's do that. So let's go to our CloudFormation window now. So we have to create a S3 bucket. So we'll scroll down to the S3 service. So here is the S3 service. We'll click on the S3 service. We'll click on bucket and drag it over here, right? So this is our S3 bucket, guys. Now you can edit the name of the template over here. You can name it as Edureka CF. That means Edureka CloudFormation, right? So you specified that. Now this is your JSON code. Now you can compare the JSON code, guys. Let me make it a little bigger for you guys. Yeah, so this is the JSON code, guys. Now I didn't code this JSON script, right? I just dragged and dropped this bucket over here in CloudFormation, and it automatically generated the script. Comparing it with the code that we have in our presentation, let's see. So we have resources. Yes, we have resources. We have the name of your bucket part. So basically this is the name of your bucket, and then it's a type wherein you'll be specifying the S3 service. So you have type and you're specifying the S3 service over here. Alright, so if you want to change the name of the bucket, we can do that over here. Let's specify it as Edureka CF. Alright, so we are done. So this is it, guys. This is all you have to do. So now for running this in CloudFormation, all you have to do is click on this icon, create stack. Now this will lead me to this page, which is the create stack page. Now it has automatically uploaded this template to the S3 bucket, and it has specified the URL here, right? You will click on next. You'll specify the stack names. Let's specify it as Edureka CF. Right, so you don't have to specify anything here. Let's click on next. Click on create. So you'll be seeing the events on this page. Let's refresh this. So it says create in progress, right? So my template is now being created into a stack, and that stack will have the AWS resource in it, which is the S3 bucket, right? So I think the time is enough. Let's refresh it and check if our stack has been created. So it's still in the creation phase. Let's wait. All right. So now it shows me that the create is complete. All right, guys. So let's go to our S3 service and check whether we have that bucket that our AWS CloudFormation created for us. So we'll go to the S3 service. And here it is, guys. So this is the bucket that we created, all right? And so you can see the time, it's March 28th, 2017. Today is March 28th, 2017, and the time is 7:05 and the time is 7:07 here, all right? So this bucket has just been created by CloudFormation. So guys, like I said, it is very easy. It is easy to understand and to deploy as well. You basically just have to create a template, and that is it. AWS CloudFormation will do the rest for you. And the cool part is that you can replicate that template as many times as you want, right? So it will save you the time. Okay, this demonstration is done. So we have created an S3 bucket using CloudFormation. Let's see what our second demonstration is all about. So now we'll be creating an EC2 instance in which we'll be deploying the LAMP stack, which means in that EC2 instance, you'll be installing Linux, you'll be installing Apache, you'll be installing MySQL, and you'll be installing PHP as well, right? So let's see how will we do that. So for our second demonstration, we will again go back to the CloudFormation console. We'll click on create stack. Now we have to launch a LAMP stack. So a LAMP stack is basically a sample template in AWS, right? So we can select the sample template and we'll click on view or edit template in designer. So a LAMP stack is basically an EC2 instance with Linux, Apache, MySQL and PHP installed onto it, right? You can see in the designer that you have only specified an EC2 instance and you've attached a security group to it. So you need the security group obviously because you have to connect to this EC2 instance, right? Now a LAMP stack is basically a web server, remember? Now let's see the template for this LAMP stack. So we discussed the structure of a JSON document, if you guys remember. So the first part was the AWS template format version, then you have description, then you have parameters. So parameters, if you guys remember, it is basically the values that you'll be passing to the template, right? Now if you're creating a LAMP stack, you'll be needing the database name, you'd be needing the database password, you'd be needing a lot of things, right? If you're installing MySQL, you'd be needing the username, you'd be needing the password. So all of that you can feed in here in the parameters. So you can specify the key name. So if you are connecting to the EC2 instance through SSH connection, you'd be needing a key pair, right? So you'll be specifying the key pair here. Then you'll be specifying the DB name and the other details. Now how will that look when you'll be creating a stack? So let's do that. We'll click on this icon which will now create a stack automatically. So you'll be prompted on this page, click on next. Then you will reach this page wherein you are feeding the entry, right? So you would specify the stack name. So this is by default. So stack name, so we'll be specifying the stack name first. So let us stack name be LAMP demo. And then we move on to the parameters part. So whatever you specified in the JSON parameters field will be reflected over here. So we specified DB name over here. So it is asking me for the DB name. So let's give it as Edureka and let's give the DB password as something. Can DB root password, DB user as Edureka. Instance type as t1.micro. Why t1.micro? Because if you guys noticed in the template, we didn't specify a virtual private cloud. That is a VPC. Now all the instances which are launched these days, of which all the new instances which are there in EC2 are to be by default launched in a VPC. But since we are creating a JSON file and we didn't specify a VPC, you have to select an older version of your EC2 instance. So let it be T1. So T1 is an older version. It runs without a VPC as well. And then you have to specify a key name. The key name would basically be used to create a SSH connection to your instance, right? So our key pair was edureka_a. We'll select that and we'll click on next. Now SSH location is basically your IP address if you want to specify. I don't want to specify it, so we'll click on next. You don't have to enter anything over here. Click on next, confirm and click on create. Now is happening in the background is it is picking up that JSON file and is creating a stack for us. Launch an EC2 instance. It will then install Linux onto that. It will then install Apache, MySQL, and then in the end a PHP installation. So what we will do, once it says that the creation is completed, we will go and check if everything has been installed on our server by creating an SSH connection, right? So let's wait until this stack is complete. Alright guys, so as you can see in the events that the creation is now complete. So let's check that if our installation has been correct. We'll go to the EC2 instance. Now this is our instance which has just been created. We can check that it's been created on March 28th, right? So today is 28th. Alright. So now let's connect to this instance. So for that we'll have to copy the IP address. This is the PuTTY software. For those of you who don't know how to connect to EC2, you'll be pasting your IP address here, right? and then you have this private file, right? So this is of the PEM extension, but the putty software needs a PPK extension. So you have to convert this PEM file to PPK. That can be done using the PuttyGen software. So this is the PuttyGen software. So I'll be dragging this file here. Okay, it doesn't work. So we'll click on load, go to downloads, click on all files, select my PEM file, click on open, click on OK, and then click on save private key. So let's name it as edureka_a, click on save. So my file has been saved. We'll close it, go back to our putty software. You have entered the IP address here. You'll click on SSH, click on authentication, click on browse, go to your PPK file, click on open, and click on open here. So now you'll be connected to your SSH, through your SSH to your EC2 instance. So any Linux installation on your AWS infrastructure, the login will be EC2-user. Alright, so you're in. Let's see if we can connect to our MySQL installation. So MySQL-edge, so it is on localhost -p port number 306, and then the user that we gave was edureka, and the password was this. Okay guys, so we are in. So that means we successfully created the edureka username, which we specified in the JSON script. That works well. And then you specified, okay, we also specified that we need a database, right? So let's see if it is showing our databases, or our databases have been created as well. Okay, so it has a database called edureka, right? So the JSON script worked well. Now the thing here to notice is that how granularly you can configure your JSON file, right? First of all, it launched an EC2 instance, then it installed Linux, then it installed MySQL, it configured its settings, and inside MySQL it gave you a database, right? So this is awesome, guys. So this gives you the whole control of AWS just through JSON script, right? And this is the power of CloudFormation. Now, if you want this infrastructure or whatever you have created right now to be replicated again to some other instance, that can be done with a single click of a button, right? And it is actually pretty awesome, because if you were to install this LAMP stack on a server or on AWS, again, if you launch a EC2 instance with a Linux OS, installing Apache, MySQL, and PHP may take time. It actually takes time because you have to open the console, you have to open the terminal, you have to enter the commands, and depending on your internet speed, you will install all those packages. So this is neat. It does everything for you automatically, right? So guys, this is what CloudFormation was all about. So I'll close this session. Let me go back to my slide. All right. So guys, we are done with the LAMP stack demo. Okay guys, so this brings us to the end of our session. Any doubts that you guys have, anything that you didn't understand throughout the session, anything that you have in mind about CloudFormation that you're not clear of, you can ask now. Okay, John says, thank you for the session. You're welcome, John. Others are giving me a go. Okay guys, so since most of you are giving me a go, let me end the session. So thank you guys for attending today's session. Your assignments have been given to you in your LMS. They have been uploaded into your LMS. In the next session, I expect you guys to complete your assignment and also practice the hands-on part that we did today. All right. So until then, see you guys. Have a nice day.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!
Hello guys, I am Vishal from Edureka and I welcome you all to yet another session on AWS. In today's session, we would be understanding what AWS CloudFront is. But before we do go ahead and understand what CloudFront exactly is, let's start by taking a look at today's agenda first. First and foremost, I would be talking about what AWS exactly is. We'd also understand why do we need AWS CloudFront and what it is exactly. Then I would talk about how content gets delivered using Amazon CloudFront and what are its applications. Finally, I would finish things off with the demo part where I would be talking about AWS CloudFront distributions. Having said that, let's not waste any time and jump into the first topic of discussion, that is, what is AWS? Well, AWS stands for Amazon Web Services, which is a leading cloud service provider in the market. And it has the highest market share when you talk about any cloud service provider. Now, what Amazon Web Services does is it provides you with 70 plus services, and these services are constantly growing. To name some of these services, we have something called as your computation services, your storage services, your database services, and all these services are made available to you through cloud. That means you can rent all these services and pay only for the services that you use and only for the time duration you use these services for. If you want to know more about how AWS works exactly, I would suggest that you go through the videos that we have on YouTube. We have quite a few videos on YouTube which talk about AWS in particular. All you have to do is you have to go to our YouTube channel and type Edureka AWS, and you'd be having all the videos that are related to AWS. But that is not the discussion for today. We are here to discuss what CloudFront is, and I would like to stick to that. So coming back to CloudFront, when you talk about AWS, you have some services. Now what AWS does is it offers you various infrastructure as services and even platform as services. Now these services are made available to you in the form of infrastructures or platforms where you can actually go ahead and host your applications or websites. So when you do go ahead and host these applications online, what your cloud provider has to worry about is the way data is fetched. Because if you have a website online, now that website would be visited by quite a few people and they would be requesting particular content or data, right? So in that case, that data has to be made available to your customers. So how does it happen exactly, and how does AWS make it happen? To understand that, consider this scenario. Suppose you are a particular user and you're trying to visit a particular website, and imagine that that website is based somewhere at a very far location. Suppose you're based somewhere in USA and that website, its server actually hosts or is based in Australia. Now, in that case, when you make a request for particular object or particular image or maybe content, now your request is sent to the server that is in Australia, and then it gets delivered to you. And in this process too, there are quite a few interrelated networks that deal which you are not aware about. The content directly gets delivered to you and you have a feeling where you feel that you type in a particular URL and the content is directly made available to you. But that is not how it works. Quite a few other things happen in the interim. And due to that, what happens is the data that gets delivered to you, it does not get delivered to you very quickly. Why is that? Because you'd be sending in a request, it would go to the original server, and from there the content is delivered to you. Now, if you are based in USA, the situation would be convenient if the data is delivered to you from somewhere close by. Now, when you talk about a traditional system where you are sending a request to somewhere in Australia, this is what happens. Your data or your request is sent to the server based in Australia, and then it processes that request and that data is made available to you, which gets delivered to you. But if you have something like CloudFront, what it does is it sets in an intermediate point where your data actually gets cached first. And this cached data is made available to you on your request. That means the delivery happens faster and you save a lot of time. So how does AWS CloudFront exactly do it? Let's try to understand that. Well, when you talk about AWS CloudFront, what it does is first and foremost, it speeds up the distribution process, and you can avail any kind of content, whether it's static or dynamic, and it is made available to you quickly. What CloudFront does is it focuses on these 3 points. One is your routing, 2 is your edge locations, and 3 is the way the content is made available to you. Let's try to understand these one by one. When you talk about routing, I just mentioned that the data gets delivered to you through a series of networks. So what CloudFront does is it ensures that there are quite a few edge locations that are located close to you, and the data that you want to access, it gets cached so that it can be delivered to you quickly. And that is why the data that is being delivered to you is more available than in any other possible case. So what happens exactly, and how does this content gets delivered to you? Let's try to understand this with the help of this diagram. Suppose you are a user So basically what you would do is you would send in a request that needs to reach a particular server. Now in this case, what happens is first your request, it goes to an edge location and from there to your server. To understand this too, you have to understand two scenarios. First and foremost, suppose you are based in USA and you want to fetch a particular data that is based in Australia, you would be sending in a request. But what AWS does is instead of sending that request directly to your server, which is based in Australia maybe, it has these interim edge locations which are closer to you. So the request, it goes to the edge location first and it checks whether the data that you're requesting is already cached there or not. If it is not cached, then the request is sent to your original server. And from there, the data is delivered to the edge location. And from there, it comes to you. Now, you might wonder, as in, this is a very complex process. And if it is taking these many steps, how is it getting delivered to me quicker than in normal situation? Well, think of it from this perspective. If you do send in this request directly to the main server, again the data would flow through some network and then it would be delivered to you. Instead, what happens here is at your edge location, the data gets cached. So if you request it again, it would be delivered to you quicker. If it is requested by anyone else, it would be delivered to them quicker. Plus, how edge locations work is when you do send in this request and when the edge location fetches this data from your so-called original server, in that case too, when the first byte it arrives at your edge location, it directly gets delivered to you. And how does this content exactly get stored here? Well, first and foremost, what happens is what your edge location has is it has some regional cache as well. Now this cache would basically hold all the content that is requested more frequently in your region. Suppose a website has some number of content and out of it, some content is kind of requested a lot in a particular region. So surrounding that region, the closest edge location would have a regional cache which would hold all the content that is more relevant for those users so that it can be frequently delivered to these users and can be made available to them quickly. In case if this data gets outdated and it is no longer being requested, then this data can be replaced with something else that is requested more frequently. So this is how CloudFront works. What it does is it creates a distribution and you have some edge locations through which you can actually request that data faster. So what are the applications that CloudFront has to offer to you? Now, I won't say applications. Instead, I would say some of the benefits of using CloudFront. Let's try to understand those one by one. First and foremost, what it does is it accelerates your static website content delivery. We just discussed that. That means if you're requesting a particular image or something like that, it gets delivered to you quicker. Why? Because it is cached at your edge location and you do not have to worry about any latency issues. Next, what it does is it provides you various static and even dynamic content. Suppose you need some video or a live session or something like that. Even that gets delivered to you quickly. I just mentioned that when you request a particular thing, when the first byte it arrives at your edge location, your CloudFront starts streaming that to you or start delivering that to you. Same happens with your live streaming videos as well. You would be getting that streams instantly without any latency whatsoever. Encryption. Now, when you do access this content, what AWS CloudFront does is it lets you have this so-called domain where you put in HTTPS and you get secured data. So you already have one layer of security, but it also lets you add another layer of security by giving you something called as encryption. By encrypting your data or by using your key value pairs, which is the same, you're actually ensuring that your data is more secured and it can be accessed privately as well. Customization at the edge. Now, what do I mean by this? Now, there is some content that needs to be delivered to the user or to the end user. If the customization it happens at the server, again, it might be time consuming and there are quite a few drawbacks of it. Say, for example, I need a particular content and it needs to be processed or customized at the very last moment. So these things can be done at the edge location as well, thus helping you save time, money, and various other factors as well. And finally, what it does is it uses something called as Lambda Edge, which again lets you deal with various customizations and lets you serve your content privately. So these were some of the applications or uses of CloudFront. What I'm going to do now is I'm going to switch into my AWS console and I'm going to talk about AWS CloudFront distributions and how can you go ahead and create one. So stay tuned and let me quickly switch into the console first. So yes, guys, what I've done is I've gone ahead and I've logged into my AWS console. Now, for people who are completely new to AWS, what you can do is you can actually go ahead and create a free tier account. You have to visit AWS website and search for free tier. You would get this option. Just create an account. They would ask you for your credit or debit card details probably, but they won't charge you. A minimal amount is charged and that is reverted back to your account. That is for verification purpose. And after that, what AWS does is it offers you certain services which are made available to you for free for one complete year. That is, as long as you stay in the limits or the specified limits which AWS has set. So those limits are more than enough to practice or to learn AWS. So if you want to do go ahead and get a proper hands-on on various AWS services, I would suggest that you do visit their website and create this free tier account. Once you do have that account, you have all these services that are made available to you. As I just mentioned, there are 70 plus services, and these are the services that are there, which you can actually go ahead and use for different purposes. Our focus today, however, is creating a cloud front distribution, which we just discussed in the so-called theory part. I would be repeating few topics here too while we do go ahead and create our cloud front distribution. Now, as I've already mentioned, we want to fetch data or fetch a particular object, and if that is placed at a particular edge location, that would be made available to me. So what we are doing here is, imagine that our data is placed at a particular original server. In our case, let's consider it as an S3 bucket. Now, S3 is nothing but a storage service with AWS, that is simple storage service rather, that is SSS, and that is why we call it S3. So what we are going to do is we are going to go ahead and create an S3 bucket. In that, we would be putting in certain objects and we would be accessing that by using our Cloud Run distribution. So let's just go ahead and create a bucket first. You can see we have S3 in my recently used services. You can just type S3 here and that would be made available to you. You can click on it and your simple storage service opens. You would be required to go ahead and create a bucket. This is how you do it. You click on create and you give it some name, say maybe bucket, use small letters, bucket for AWS demo maybe, and I would give in some number 000. I say next, next, next. I need a basic bucket, so I won't be putting in any details. Do we have a bucket here? There you go. We have a bucket here. And in this bucket, what I'm going to do is I'm going to put in some content that we can actually request for. So let's just go ahead and create an HTML file and put in maybe an image or something. So I have a folder here. In that folder, I have a logo of Edureka. I would be using that logo and I would want to go ahead and create an HTML file which I can refer. So I would open my notepad and I would write a simple HTML code. I won't get into the details of how to write an HTML code. I assume that you all know it. If not, you can use this code. So let's create a head file basically, or a head tag rather. Let's say demo tag maybe. And I close this head tag. I need some body in here, right? So let's say, let the body be say, welcome to Edureka. And I end the body here. And I save this file. I say save as. Where do I want to save it? And save it here, and I would save it as say maybe index.html. I say save. It probably got saved somewhere else. Let me just copy it and paste it here. I've done that. This is the file. Now we have these files. Let's upload it to our S3 bucket. Come here, I say upload. I want to add files. So add files. Where do I go? I go to the F folder, I go to demo and I select these two files and I say upload. There you go, my files are here and I say upload. Small files, so should not take a long time. 50% successful, 100% successful. There you go, you have these two files. Now we have our S3 bucket and we have two files. This is our origin server. Now I need to create a distribution and use it. To do that, I would click on services and come here and I would search for CloudFront. There you go. And I say create a distribution. So I click on this icon. Now you have two options. First one is something that lets you have your static data moved in or moved out. Or if you want to live stream your data, you should go for this option, but that is not the case. We would be sticking to this thing. I say get started. I need to enter in a domain name. So it gives me suggestions, and this is the first one which I just created. Original path is something that you can give in for the folders from where you want to access the data, but mine directly resides in the bucket. There are no extra folders, so I don't need to enter anything. Original ID, this is what I have here. Basically, I can use this, or I can just go ahead and change the name if I want to, but I would let it stay the way it is. Restrict bucket access, yes, I want to keep it private, so I say restrict, and I create a new identity. And there you go, I have a new user created here. Apart from that, grant read permissions on bucket. Yes, update my bucket policy accordingly is what I would say. Then I would scroll down, customer headers and all. I don't need to put in these details. How do I want my data to be accessed? The protocol policy. I would say redirect HTTP to HTTPS so that it is secured. If I scroll down, I have some other options as well. Cached HTTP methods and all those things. Do I need to change these? Object caching, can I customize it? Yes, I can, but again, I would be using the by default one. If you want to, you can customize it. Smooth streaming, no, these are some of the things that you need to focus on. If you have some streaming data, you can put in details accordingly, but we are not doing that. What is the price class that you want to choose? You have some options here which you can pick from. I would be going for the default one. And then I just scroll down and I say create a distribution. So your distribution is getting created now. And this process might take a longer while. If you click on this thing, you'll realize that it is in progress, and it takes somewhere around 10 to 12 minutes for this distribution to get created. So meanwhile, I'm gonna pause this session and I would come back with the remaining part once this distribution is completed. So bear with me for that while. So there you go. The distribution has been deployed. The status is deployed here. So we can actually go ahead and use this thing. Now we have a domain name here which I can use, and I can just enter it here and we would be redirected to the page. And what happens here is you would be actually given access to this page through the edge location. That means you're not going to the server. Instead, the data is being cached to you from your distribution or your edge location rather. So you enter this website and you hit the enter button. There's an error. It shouldn't have been. Oh, I know what just happened. When you do go ahead and create your so-called distribution, in that you actually have an option of selecting a by default file, which I did not. So I'll have to give in an extension here saying slash index.html. And if I hit the enter button now, it should redirect you to the demo tag, which says welcome to Edureka, right? So this was the HTML file that we created. And we also had a PNG file which we wanted to access. The name was logo.png. Okay, this is funny. This should not happen. Why is this happening? Let's take a look at it, whether we have that file there, because if it was there, we should be able to access it. And what was my bucket? This was the one. Oh, this has happened. When I uploaded that file, it got saved with this extension .png. So if I come here and I type .png here, there you go. You have that object delivered to you through your so-called distribution. So yeah, this was about CloudFront. I hope you all had something new to learn and understand. If you do have any queries, put those queries in the chat box below and we would be more than happy to get back to you with the answers as soon as possible. As far as this session goes, I would be resting it here. Thank you. Bye-bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
Hello everyone, I'm Archana from Edureka. In this session, we will be discussing about Amazon CloudWatch. So without any delay, I'll walk you through the topics which we will be discussing today. Firstly, we will see what Amazon CloudWatch is and why do we need it. Then we'll discuss certain Amazon CloudWatch concepts. Moving on, we'll take a look at two most important segments of Amazon CloudWatch, which are Amazon CloudWatch events and Amazon CloudWatch logs. And finally, to make this all more fun and interesting for you, I've included a demo as well. So let's get started. First, let us try to understand why we need cloud-based monitoring with a couple of scenarios. In our first scenario, Consider that you have hosted a messenger app on cloud, and your app has gained a lot of fame, but lately the number of people using your application has gone down tremendously, and you have no idea what the issue is. Well, it could be due to two reasons. Firstly, since your application has complex multi-tier architecture, monitoring the functionality of every layer by yourself will be a difficult task. Don't you think? And secondly, since you're not using any kind of monitoring tool here, you wouldn't know how your application is performing on cloud. Well, one solution for that is to employ a monitoring tool. This monitoring tool will provide you insights regarding how your application is performing on cloud. And with this data, you can make necessary improvements, and you can also make sure that your application is in par with today's customer needs. And definitely after a while, you'll notice that the number of people using your application has increased. Moving on to our next scenario, let's say your manager has assigned you with a project and he wants you to make this project as cost effective as possible. So as you can see in this project, you're using 5 virtual servers which perform highly complex computations. And all these servers are highly active during daytime. That is, they handle most traffic during daytime. But during nighttime, the servers are idle. By that I mean the CPU utilization of these servers during nighttime is less than 15%. And yet, as you notice here, in both the cases, you are paying same amount of money. You have to notice 2 points here. Firstly, all your virtual servers are underused during nighttime. And secondly, you are paying for the resources which you're not using. And this definitely is not cost effective. So, one solution is to employ a monitoring tool. This monitoring tool will send you notification when these servers are idle, and you could schedule to stop the servers on time. So guys, this is one way to make your project most cost effective and avoid paying unnecessary operating costs. Let's consider another scenario for better understanding. So let's say I have hosted an e-commerce website on cloud, and during sales season, many customers are trying to access my website, which is definitely a good thing. But for some unfortunate reason, application downtime has occurred. And you guys have to remember that I'm not using any kind of monitoring tool here. So it'll be difficult for me to identify the error and troubleshoot it in reasonable amount of time. And it's quite possible that in this period, my customer might have moved on to different website. So you see that I've lost a potential customer here. So if I've had a monitoring tool in the situation, it would have identified the error in earlier stages itself and rectified the problem. Well, I could have easily avoided losing my customer. So I hope guys, with help of these use cases, you were able to understand as to why we need cloud-based monitoring. So let me just summarize what we've learned till now. We need monitoring firstly because it provides a detailed report regarding performance of your applications on cloud. And secondly, it helps us to reduce unnecessary operating costs which we are paying to the cloud provider. Moreover, it detects problems at earlier stage itself so that you can prevent disasters later. And finally, it monitors the user's experience and provides us insights so that we can make improvements. So well guys, in this session, we will be discussing about one such versatile monitoring tool called Amazon CloudWatch. Amazon CloudWatch basically is a powerful monitoring tool which offers you a most reliable, scalable, and a flexible way to monitor your resources or applications which are currently active on cloud. It usually offers you with 2 levels of monitoring, which are basic monitoring and detailed monitoring. If you want your resources to be eligible for basic monitoring, all you have to do is to sign up for AWS free tier. In basic monitoring, your resources are monitored less frequently, like say every 5 minutes, and you're provided with a limited choice of metrics to choose from. Whereas in detailed monitoring, all your resources are monitored more frequently, like say every 5 minutes, and you're provided with a wide range of metrics to choose from. But if you want your resources to be eligible for detailed monitoring, you'll have to pay a certain amount of money according to AWS pricing details. Now, let's have a look at few monitoring services offered by Amazon CloudWatch. Amazon CloudWatch, firstly, it provides a catalog of standard reports which you can use to analyze trends and monitor system performance. And then it monitors, stores, and provides access to system and application log files. Moreover, it enables you to set up high-resolution alarms and send notifications if needed. And Amazon CloudWatch also sends system events from AWS resources to AWS Lambda functions, SNS topics, etc. So if you have not understood any terms which I've used here, don't worry, we'll get to know more about these terms as we progress through the course of this session. Earlier, I mentioned that Amazon CloudWatch allows administrators to monitor multiple resources and applications from single console. These resources include virtual instances hosted in Amazon EC2, databases located in Amazon RDS, data stored in Amazon S3, elastic load balancers, and many other resources like auto-scaling groups, Amazon Cloud Trail, etc. So guys, now let's try to understand Amazon CloudWatch a little deeper. Firstly, we'll have a look at few Amazon CloudWatch concepts, and then I'll explain you how Amazon CloudWatch actually operates. So it's metric. A metric represents a time-ordered set of data points that are published to cloud. So what I mean by that is, suppose let's say you have three variables x, y, and z, and you have created a table which has values of x with respect to y over a period of time. In this scenario, the variable x which you have been monitoring till now is a metric. So you can think of metric as a variable which needs monitoring. Next we have dimensions. Let's consider same variables x, y, and z. Previously you had created a table which has values of x with respect to y. Now let's create another table which has values of x with respect to z. So basically we have two tables which describe same variable x but from two different perspectives. These are nothing but dimensions. So basically a dimension is a name value pair that uniquely identifies a metric. And Amazon CloudWatch allows you to assign up to 10 dimensions to a metric. Then you have statistics. Previously we had created two tables which had values of x with respect to y and as well as z. You can combine data from these tables like to create a chart or maybe plot a graph for analytical purposes. This combination of data is nothing but statistics. Statistics are metric data aggregations over a specific period of time. Then you have alarm. Let's say you have been monitoring this variable x for some time now and you want a notification to be sent to you when the value of x reaches certain threshold. All you have to do is set an alarm to send you notification. So basically, alarm can be used to automatically initiate actions on your behalf. Now that you have clear understanding of concepts of Amazon CloudWatch, let's see how Amazon CloudWatch operates. Amazon CloudWatch has complete visibility into your AWS resources and applications which are currently running on cloud. So firstly, it collects metrics and logs from all these AWS resources and applications. And then by using these metrics, it helps you visualize your applications on CloudWatch dashboard. Moreover, if there is some sort of operational change in AWS environment, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective action, like maybe it sends you a notification or it might activate a Lambda function, etc. And finally, it provides you real-time analysis by using CloudWatch Metric Math. So if you're wondering what CloudWatch Metric Math is, it is a service which integrates multiple CloudWatch metrics and creates a new time series. And you can view this time series on CloudWatch dashboard as well. So working this way, Amazon CloudWatch provides you with system-wide visibility. It even provides you actionable insights so that you can monitor your application performance. Moreover, it allows you to optimize resource utilization if needed. And finally, it provides a unified view of operational health of your AWS environment. So I hope that by now you know what Amazon CloudWatch is. So now let's try to understand how Amazon CloudWatch works with help of a demo. So guys, this is my AWS console. Let's say AWS Management Console. And the services which you can see on the screen are the services offered by Amazon AWS. But in this demo, we're going to use only few services. Let's say CloudWatch, and then you have EC2 and a service called Simple Notification Service. And when I click on EC2, it takes me to EC2 dashboard where you can see that I have 4 instances which are currently active. You know that here in this demo, I'm supposed to get a notification saying that CPU utilization of my instance is less than 25%. For me to receive a notification first, I'll have to create a topic and subscribe to it with my email ID. So let's explore a service called Simple Notification Service, where you can create a topic and subscribe to it. Once you reach SNS dashboard, click on Topics option on the navigation pane and click a Create New Topic. Give your topic a name. Let's say CW topic and give the display name as well. Let's give the same name. and click on create topic option here. You can see that I've successfully created a topic. Now click on the topic which you have created and select actions and subscribe to topic option. Well, I want notification to be sent to me in form of email. You have different options as well in form of Lambda function or JSON, etc. But I'm going to choose it as email and give my email ID, which is here, and then click on create subscription option. So now whenever AWS console wants to send me a message, it will send to the email ID which I used to subscribe the topic. Now let's go back to CloudWatch dashboard. So guys, this is my CloudWatch dashboard and you can see different options on navigation pane. Firstly, I have dashboard where I can view all my metrics at same place. Then you have alarms, which shows the list of alarms which you have configured. And then you have events and logs, which we'll be exploring later. Our topic of interest is the last one, which is metrics. Select the metrics option here and then choose EC2 and then per instant metrics. When you do that, a list of metrics will be shown to you like network out, CPU utilization, network packets in, network packets out, and various other metrics for various resources which are currently active on your cloud. So, but we are interested only with CPU utilization. So I'm going to type that here. Well, it shows the list of instances which are active on my cloud. And I'm going to choose Windows 2 instance and then click on graph metrics option here. Okay, let's select Windows 2 only. And then on the right side, you can see you have a alarm button. When you click on that, a dialog box will be open where you can configure your alarm. Firstly, let's give alarm a name. Let's say low CPU utilization and a brief description as well. Let's say lower than 25%. Lower than 25% CPU utilization. Now I'm going to set the threshold, which is less than 25% in this case. And on the right side, you can see a period option. If your resources are eligible for basic monitoring, this period option by default is 5 minutes. And if your resources are eligible for detailed monitoring, it's usually 1 minute. And when you scroll down, you can see a send notification to option here. So select the topic which you have previously created. That will be C topic in my case, and then click on create alarm. Well, there is some error. Okay, it says there's an alarm already with this name. So let's give it another name of my instance. Now let's try again. And when you click on this alarm button and click on refresh option here, it says that I've successfully created an alarm. Here you can see that low CPU utilization of my instance. And when you click on that, it shows you all the details like description, threshold, and what action it is supposed to take when alarm is configured and all the details. So guys, try it out. It'll be easy for you to understand CloudWatch console much better. Okay guys, now you know what Amazon CloudWatch is, what it does, and the way it operates. But to understand the capability of Amazon CloudWatch completely, we should be aware of two important segments of Amazon CloudWatch, which are CloudWatch events and CloudWatch logs. So let's discuss them one by one. Firstly, we have Amazon CloudWatch events. Consider the scenario. Let's say you've created an auto-scaling group, and this auto-scaling group currently has terminated an instance. So you can see this as some sort of operational change in AWS environment. When this happens, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective actions. Like in this case, it might send you a notification saying that your auto-scaling group has terminated an instance, or it might activate a Lambda function which updates the record in Amazon Route 53 zone. So basically what Amazon CloudWatch events does is it delivers a real-time stream of system events that describe change in your AWS resources. Now let's have a look at few concepts related to CloudWatch events. Firstly, we have event here. An event indicates change in AWS environment, and AWS resources generate events whenever the state changes. Let's say you have terminated an active EC2 instance. So the state of this EC2 instance has changed from active to terminated, and hence an event is generated. Then you have rules. Rules are nothing but constraints. Every incoming event is evaluated to see if it has met the constraint. If so, the event is routed to target. Target is where the events are handled. Target can include Amazon EC2 instances or a Lambda function or an Amazon SNS topic, etc. Now let's try to understand Amazon CloudWatch events better with help of use case. In this use case, we are going to create a system that closely mimics the behavior of dynamic DNS. And for those who don't know what dynamic DNS is, let me give an example. Let's say you want to access internet at home. Then internet service provider assigns you an IP address, but since internet service provider uses different kind of online systems, this IP address keeps changing. Because of which it might be difficult for you to use this IP address with other services like webcam, security camera, thermostat, etc. So this is where dynamic DNS comes into picture. What dynamic DNS does is it assigns a custom domain name to your home IP address. And this domain name is automatically updated when IP address changes. So basically, dynamic DNS is a service that automatically updates a name server in domain name system. And Amazon offers you with a similar kind of service called Amazon Route 53. So in this use case, we are going to update Amazon Route 53 whenever an Amazon EC2 instance changes its state. Now let's see how the use case actually works. This use case precisely works this way. So whenever an EC2 instance changes its states, Amazon CloudWatch event becomes aware of these operational changes and it triggers a Lambda function. This Lambda function uses different kind of information regarding the instance like its public and private IP address, and it updates a record in appropriate Route 53 hosted zone. So let's say you have an EC2 instance and you have terminated the instance. So Amazon CloudWatch events become aware of this and it triggers a Lambda function. And this Lambda function deletes the record from Amazon Route 53. Similarly, if you have created a new instance, again Amazon CloudWatch events become aware of this and it triggers a Lambda function, and this Lambda function creates a new record in Amazon Route 53. I hope you have understood what Amazon CloudWatch events is and what it does. Now let's discuss how Amazon CloudWatch events works with help of a demo. So in this demo, we will schedule to stop and start EC2 instances with help of Lambda function and CloudWatch events. So let's go ahead with demo. So guys, you can see that I have 4 instances which are currently active. First, I'm going to create a Lambda function which is going to stop my Windows 2 instance. And you guys need to know that for Lambda function to do that, we need to assign permission. So Amazon provides you with a service called IAM, which is Identity and Access Management, where you can assign permissions. When you search for IAM in the tab, it shows you the service. Select that. And on IAM dashboard, on the navigation pane, you can see a policies option here. Select that and click on create policy option. First, it's asking you for a service here, which will be EC2 in our case. Click on EC2 function, then actions, which will be to start and stop my EC2 instances. So let's search for start instance. Well, a predefined function is already there, so you can choose that. Then you have stop instance. Again, select that. And then I want this to be eligible for all the resources, so I'm going to choose all resources here and click on review policy option. Let's give our policy a name, that is to start and stop EC2 instances, and description as well. A brief description, let's say to start and stop instances. And now click on create policies. It's taking a while. So I've successfully created a policy here. Next, we have to assign this policy to Lambda function. So click on roles here, then click on create role, choose Lambda function here and click on next permission. Search for the policy which we have created earlier, that is to start and stop. I found the policy, select that and click on next review option. It's asking for a name. Let's give a name. Start, stop instances and click on create role. I've successfully created a role. So what we have done here is we have assigned permission for Lambda function to control EC2 instances. Now let's create a Lambda function. You can search for Lambda in the search tab and there click on create function. Give your Lambda function a name. Let's say to stop instance and select the role which you have previously created and click on create function. You can see that I've successfully created a Lambda function. And now I'm just going to copy the code to stop EC2 instances here. I'm going to select this and paste it over here and make sure to save it. As you can see here in this function, it asks for instance region and instance ID. So let's configure the details. Let's give it as stop instance. And here you'll have to insert instance region and ID. Instance region and instance ID. Now we'll have to copy the instance region and ID of the instance whichever we need. So let's go to EC2 dashboard here. Now let's say I want my Windows 2 instance to be stopped. This is the instance ID which I'm going to paste it over there. Similarly, instance region now. Well, in this case, I'm choosing Windows 2 instance. You can choose whichever instance you want to stop. Once you're done that, you click on create option here. Test the configuration details. When you scroll down, you can see the execution results here. It says that my instance has been successfully stopped. Let's go and check in the EC2 dashboard. Here on the EC2 dashboard, I'm going to refresh it. And you can see that my Windows 2 instance has successfully stopped. Now we'll create another Lambda function which will restart this function. Again, the same, search for Lambda function in the search tab and click on create function option. It asks for a name, so let's say start instance, and choose the role which you have previously created and click on create function. Again, you'll have to paste the code to start the instances over here and click on save option. Let's try to configure this. Let's name it as start instance. And again, it asks for two attributes which are instance region and ID. Now all we have to do is copy the instance region and ID here like we did earlier. Let's go to EC2 dashboard and copy the instance ID and region. Well, you guys can see that here my Windows 2 instance has been successfully stopped. Now I'll copy this and paste it over there. Similarly, instance region as well. And click on create option. Now test the configuration. And when you scroll down, you can see that my instance has successfully restarted. In the EC2 dashboard, I'm going to refresh this. Well, my Windows 2 instance is on its way to get restarted. Till now, I've used Lambda function to start and stop my instances. But now I'm going to automate this process with help of Amazon CloudWatch. So let's go to CloudWatch dashboard here. Well, it's taking a while to load. Then choose events option and click on create rule. So here we're going to schedule to stop my instances every day at 6:30 p.m. and to restart this instances every day at 6:30 a.m. So click on schedule. If you want to know more about cron expressions, you can visit Amazon documentation. So let me show you. It has 6 fields. Firstly, it's minutes, then you have hours, then day of month, day of week, and year. We're concerned only with minutes and hours because we want our instances to be start and stopped every day, every month. So let's give the details. So if you're going to create a rule to stop the instance, let's say 6:30 in the evening, 30 minutes and 18, which is nothing but 6 p.m. And then rest all, you don't have to mention anything. When you give a proper cron expression, sample timings will be provided to you. You can see here the rest of the sample timings. And now let's add a target function, which is Lambda function in our case, and select on stop instance function and click on configure details. Give your rule a name. Let's say stop my EC2 instance, and description to stop my EC2 instance at 6:30 p.m. every day, and click on create rule here. You can see that I've successfully created a rule to stop my instance every day at 6:30 p.m. Now let's create another rule to restart this instance every day at 6 a.m. in the morning. Again, the same. Choose the schedule here and cron expression, which will be 6 a.m. in the morning. Again, the sample timings are shown here. Then let's add target function, again Lambda function, and select the function that is to start instance and click on configure details. Let's name it as start my EC2 instance and description as to start my EC2 instance every day at 6 a.m. and click on create rule. So now we have successfully created 2 rules to start and stop the EC2 instances at 6:30 p.m. and 6:30 a.m. respectively. So what we have done is we have saved our time here. we've automated the process of stopping and starting EC2 instances. So try it on yourself. It'll be easier for you to understand. So guys, now let's discuss our next topic, which is Amazon CloudWatch logs. Have you guys heard of log files? Well, log files are nothing but detailed record of events that occur when you're using your AWS environment. You can view your log files on your on-premise server as well. Search for an app called Event Viewer. Select the app and click on Windows Logs and select Systems. A list of log files will be shown to you. When you choose a particular log file, all the details regarding that log files will be shown, like the number of keywords, the login time, number of hours the file has been logged onto, and various other details. Similarly, you have log files created when you use AWS environment as well. So you can consider these log files as a data repository. Most of the metrics are generated from these log data. So whenever a metric is generated, a part of data is extracted from this log data. So you're designing metrics according to your like by choosing a part of data from this log data. So basically these log files are what you call a primary data storage place. And Amazon CloudWatch logs is used to monitor, store and access log files from AWS resources like EC2 instances, CloudTrail, Route 53, etc. Let's try to understand CloudWatch logs better with help of some features. Firstly, you can use Amazon CloudWatch logs to monitor your application and system log files. Let's say you have made a lot of errors but trying to deploy your application on cloud. In this scenario, you can use CloudWatch logs to keep track of your errors and send a notification to you when the error rate increases certain threshold so that you can make avoiding errors again. Then you have log retention. By default, logs are kept indefinitely. But CloudWatch provides you with an option where you can set the period between 10 years to 1 day. Then you have log storage. You can use CloudWatch logs to store your log data in highly durable storage. And in case of system errors, you can access raw log data from this storage space. And then you have DNS queries. You can use CloudWatch logs to log information about the DNS queries that Route 53 receives. Now let's have a look at few concepts regarding CloudWatch logs. Firstly, we have something called log event. So log event is just a record of activity that has occurred in AWS environment. It's straightforward. Then you have log stream. A log stream is a sequence of log events that have same source. Then you have something called log group. Log group defines group of log streams that has same monitoring and access control settings. By default, you have to make sure that each log stream belongs to one or the other log group. Guys, now let's try to understand CloudWatch logs better with help of this use case. In this use case, we are going to use Amazon CloudWatch logs to troubleshoot the system errors. You can see that I have 3 instances here and a CloudWatch agent which is monitoring all these 3 instances. So what CloudWatch agent does is it collects custom level metrics from all these EC2 instances, and then all these metrics and logs collected by the agent are processed and stored in this Amazon CloudWatch logs. Amazon CloudWatch logs then continuously monitors these metrics, as you can see here. By then, you can set an alarm which will send you notification when some sort of error occurs in the system. So whenever you receive a notification saying that some sort of error is there in your system, you can access the original log data which is stored in CloudWatch logs to find the error. So this is how you can use Amazon CloudWatch logs to troubleshoot the system errors. So basically you are having a look at original data so you can solve your problems faster and quicker. So this is it, guys. I hope the session was informative. If you have any queries, you can post them in the comment section below. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
In today's fast-paced business world, it is imperative for organizations to have the insight and the data they need in order to make right decisions at right time. Business intelligence is the key to making those correct decisions as it combines data, technology, and analytics to predict future business trends. Hello everyone, I'm Archana from Edureka, and I welcome you all to this session on Amazon QuickSight, a business intelligence tool by Amazon. So without any delay, let me give you a brief overview of what we will be discussing today. Firstly, we'll try to understand what business intelligence is. Then, we'll take a look at Amazon QuickSight, a business intelligence tool by Amazon. Moving on, we'll try to understand QuickSight a little better with help of an example. Then, we'll discuss its key features. And finally, we'll try to create some data visualizations using QuickSight so that you understand QuickSight practically. I hope the agenda was clear to you guys. So let's get started. Are you a book person? Well, I am. I read quite a lot of books. And there was this one time where I'd been to library and it took me a while to find the book which I wanted. This was mainly because in the library where I'd been to, books were not properly arranged. They were just placed randomly here and there on different cupboards. They were all mixed up. In the end, I had to take library assistant help. Even then, it took a while to find the book. But the next time I went there, all the books were properly arranged in shelves. Moreover, they were labeled and categorized. Like science fiction books were kept on one side, history and literature on different side, mystery and romance novel on other side. You got my point, right? And this time, I was easily able to find the book which I wanted, mainly because they were all properly arranged and labeled. And I didn't have to take library assistant's help as well. And I'm sure you might be wondering how this scenario is related to business intelligence at all. If you notice, when the books were all properly arranged and labeled, I was easily able to find the book which I wanted. Similarly, what business intelligence does is it takes vast amount of data that's being generated daily and structures it and presents it in a meaningful, actionable way. This way, organization can make better decisions at faster rate, and moreover, they can plan for future business strategies. There are quite a lot of definitions you'll find for business intelligence. But in simple terms, business intelligence is all about delivering relevant and reliable information to right people at the right time. Well, that being said, let's go ahead and take a look at few buzzwords which are related to business intelligence. Firstly, we have performance management. Performance management is basically making sure that the goals which you might have set for yourself or your company are being met in an efficient manner. This performance management can focus on performance of an entire organization or a single department of your organization or even an individual employee of your organization. So basically, you're using different kind of BI strategies here to keep track of performance, may it be your organization or a department or even a single employee. Then we have data wrangling. As you know, on daily basis, companies are generating mounds of data. So what data wrangling does is, it tries to collect data from different data sources and then combines this messy and complex data sets, and moreover, it structures them. This way, it will be easy for organizations to access and analyze different kinds of data. So basically, it involves 3 steps: data acquisition, and then combining this messy data and then cleansing it. Then we have data mining. Data mining is simply sorting through large data sets to identify hidden patterns. And once the patterns are found, you establish a relationship between them so that you can predict future business trends. Then we have analytics. Data analytics basically refers to using some sort of strategies or techniques to increase the productivity of your business. So you extract data, categorize it, and then perform different kind of analysis based on your needs. For example, let's say you have set up a footwear store and there are quite a lot of brands that you're selling. You can use data analytics here to predict which brand is being sold more. You can even know which brand are the customers usually preferring to buy. This way you can increase the performance of your footwear store. Then you have data warehouse. Data warehousing is a vital component of business intelligence. The first question that arises here is, what is the basic difference between a normal database and a data warehouse? Database is generated in such a way so that it can handle and monitor real-time data, as in the data which is recently generated. But data warehouse is programmed to store data for a long time. For example, let's say you have a customer, a database, and the data warehouse. This database will have most recent address of a customer, whereas data warehouse might have all the addresses that the customer has lived in for past 10 years. I hope the example was pretty clear. Then we have predictive modeling. So basically, predictive modeling is a process that combines data mining and probability to predict outcomes. So let's say your department is working on a project, and I'm sure there are certain key features which your project depends on. So what predictive modeling does is it lists all the key factors that your project depends on and then collects all the information that there is on these key factors and then formulates a statistical model. This model may use a simple linear equation or it might use some sort of sophisticated software for analytical purposes. So that was all about business intelligence and related terms. So now that you have basic understanding of what business intelligence is, let's go ahead and discuss Amazon QuickSight, a business intelligence tool provided by Amazon. Amazon QuickSight is a very simple, cost-effective and user-friendly cloud-based business intelligence tool that allows companies to create and analyze different kind of data visualizations. Moreover, QuickSight is first business intelligence service that offers pay-per-session policy. So what Amazon QuickSight does is it uses different kind of methods and programs to collect data from different sources and then runs queries against this data and creates reports. Moreover, it allows us to create different kind of dashboards and provide data visualizations so that the organizations can make better decisions. When the data is presented the way the company wants it, it becomes easy for the organizations to make decisions which otherwise would be difficult. Let's try to understand what Amazon QuickSight does with the help of a retail example. So let's say you are the manager of a retail chain that owns both stores and online shops. Customers who use your brand are provided with a customer card that they can either swipe in store or they can log into their account online by providing credentials like user ID and password. And this customer card associates everything that a customer buys either in store or online with a unique account number and stores the data in your company organization's database. This is where QuickSight comes into picture. By using Amazon QuickSight, you can analyze vast amount of data that's being stored in your organization's database. Moreover, you can run analytical reports on massive amount of customer information. By doing so, you will know if a customer is being loyal to your brand or not. You will know what products customer likes to buy and how frequently he does that. And you will also know if a customer likes visiting store or shopping online. In addition to all this, QuickSight structures and models your company data accurately, with which you can gain an unparalleled edge over your competitor. I hope the example was clear enough for you to understand how Amazon QuickSight has made its place in BI market. Now let's have a look at key features of Amazon QuickSight, which makes it more unique from other business intelligence tools. Firstly, QuickSight allows you to choose different data sources of your choice. You can upload a file or you can connect to databases like MySQL, SQL Server in cloud or on-premises. You can ingest data from various AWS data sources like Amazon Redshift, Amazon RDS, Amazon S3, etc. Secondly, it provides you with a slick and smooth engine called SPICE. The SPICE stands for Superfast, Parallel, In-Memory, and Calculation Engine. The SPICE engine is very quick and easy to use. It has a unique columnar storage and innovative data compression techniques. And using the SPICE engine, users can run interactive queries on large data sets and get rapid responses. Moreover, the SPICE engine automatically replicates the data and makes it highly available. So even if you're someone who has no prior knowledge of technologies, you can use the SPICE engine with ease and connect to a different data stores of your choice and perform analysis. Moving on, you can use Amazon QuickSight to create smart interactive data visualizations of your choice. The graphical user interface available on QuickSight dashboard is pretty simple and easy to use. So you can try out different data combinations for your analysis. Moreover, this quick sort allows you to store the data visualizations which you have created and share them with others if needed. And finally, QuickSight is highly portable and scalable. It's scalable because QuickSight can be used across several business domains to measure metrics independently. And it's portable because you can access QuickSight literally from anywhere, laptops, smartphones, tablets, etc. You just need to install the app version of QuickSight and log in using your credentials and you're good to go. So guys, that was the theory part. We have arrived at the fun part of the session, so let's go ahead and create some data visualizations using Amazon QuickSight. So guys, this is my AWS management console and you can see different type of AWS services listed here. but we are interested with QuickSight, so I'm going to type that in search tab here. Since I have used QuickSight before, it'll directly take me to the QuickSight homepage. But if you're using QuickSight for first time, you'll have to link your QuickSight account with your AWS account. Once you've done that, once you've synced your AWS account with your QuickSight account, you'll be taken to this page. As you can see, QuickSight provides you with a lot of sample data visualizations. So go ahead and have a look at them. You will understand what else you can do using QuickSight. Well, if you're trying to create a data visualization of your own, then you can go ahead and click on New Analysis option here and click on New Data Set. As you can see, QuickSight provides you with an option where you can upload a file or connect to databases like MySQL, SQL Server, or you can go ahead and inject data from AWS storage services like RDS, Redshift, S3. Well, on the right side, you can see the Spice engine while we were having a look at its features. By default, it provides you with 1 GB free space. For the purpose of this demo, I'm going to upload a file. There is this website called data.gov where you will find data sets on vast amount of topics like you have finance, then you have energy, education, agriculture, climate, research, and many other topics. So go ahead and select the data set of your choice. For this demo, I'm going to use a data set which has records of crimes that were committed in Seattle from year 1998 till 2018. When I scroll down, there's a CSV file here. I'm going to download that and upload it in QuickSight dashboard. I've attached the links for this website as well as this data set in the description part of the video. Well, I have already downloaded the file, so I'm going to upload the file. This is the file. I'm going to upload it. Well, as you know, the size of the file is pretty big. It might take a while for the file to upload. So the file has been successfully uploaded. You can always go ahead and click on this next option, which will take you directly to the data visualization page. But it's always better to prepare data. Well, you can click on this edit settings and prepare data option here. But what do I mean when I say prepare data? So when you download a file, it's possible that there might be some columns which are unnecessary for you. For example, let's say in this file, I have columns which represent the address where the crimes were committed. I have longitude and latitude as well, which I don't need. So I can go ahead and remove those columns. As you can see on the left side, there's a none option here. When I click on that, all the columns will be deleted. I can just go ahead and select the columns of my choice. Let's say I just want offense type and the year in which the offense was committed. So you can see that only 2 columns are displayed now. This way you can prepare your data. You can decide which columns you want, which columns you don't want, how many rows you want, how many rows you don't want. So according to your need, you prepare the data here. Then you click on Save and Visualization option here. On the right side, you can see that it's saying the data is being imported to the Spice engine. Well, since the file is pretty big, it'll take a while. So it says the import has been 100% success and so rows were imported to Spice engine. And here you can see the columns which I selected are displayed. And here you can see different kind of data visualization types. You can choose the data visualization type you want. You have a line graph, you have a pie chart, you have a horizontal bar graph, you have vertical bar graph, and many others. So let's get started with the first data visualization. For that, I'm going to use a heat map here. When I click on heat map, it shows various fields here. It says rows, it says columns. Suppose you're drawing a chart, then you have x-axis and y-axis. You decide which factor you need on x-axis and you decide which factor you need on y-axis. It's similar here as well. So you just have to select which field you want to add on row column and a row field. Which field you want to be displayed on row and which field on column. So well, for the x-axis, I've chosen year, and for the y-axis, I'm going to paste offense type. Sorry, I just put it in the wrong order. On x-axis, I want years, and on y-axis, I want offense type. You can see the heat map here. But the problem here is there are quite a lot of crimes and there are quite a lot of number of years. So first, I'm going to decrease the amount of years as well as crimes. So you can go ahead and click on filter option here. And let's filter year first. Right now it's showing from 1990 till 2018. Let's say we want just from 2014 till 2018. So 2014, 2015, 16, 17, and 18. Then I click on apply option here. You can see that the number of years has been customized here. It's showing just from 2014 till 2018. And the dark blue color indicates that particular crime was committed more number of times in that particular year. You can just place the cursor on any line here and it will show you the type of crime that was committed in that year. But as you can see, there are quite a lot of crimes. So let's decrease them as well. Let's see what these crimes are. It states disturbance, others, it states disturbance, noise, burglary. Okay, let's go ahead and filter that. I'm going to select offense type now. Okay, so it's showing different type of crimes here. Let's select few. Let's say bias incident, weapon. I'm just selecting some crimes randomly here. Okay, then once you've selected the crimes of your choice, click on this apply option here. You can see that the number of crimes has been narrowed down here. So it says in 2017, the maximum were burglary type of crimes, then assault using weapon type of crimes as well. Well, it says in 2014, homicide crimes were not committed. So, well, that was pretty easy, right? So based on your requirement, QuickSight provides you with an option. You can go ahead and customize the graph or the data visualization the way you want it. Let's create another visualization. Suppose you want to know out of all these years in which year the number of crimes committed for more. So you can see the add option here and click on add visual. We're just interested with year option. So I'm going to use pie chart, which will be easy for us. Again, the field wells are displayed here. Well, I've added the year to this group field. Well, it shows that in 2017, the number of crimes committed were maximum. And it shows you the count option as well. It says 21%. And in 2009, it says 11%. In 2012, 5%, which is the least out of all years. Now, let's say I want to know which type of crime was committed more in the year 2017. So I'm going to add another visual. I have filter option here, year, just year 2017. And click on apply. And we go back to visualize. I'm going to use horizontal bar chart for that. And when I click on field option here, again, it shows all the fields. Here in the group thing, I'm going to add offense type. As you can see in the y-axis, it displays year 2017. And in the x-axis, count of different types of crimes that were committed in 2017. You can see the different types of crimes have been given different color. So let's see what this crime is. It says other crime. So it's just a mix of all different type of crimes. Well, this one is theft related to car sprawl. Then you have vehicle theft here. This way you can create different data visualizations of your choice. You can further customize by using more formatting options as well. So that's it, guys. I hope you understood as to how to create different data visualizations. I've just shown few example here. Well, in the beginning, as you can see, QuickSight provides you with sample data visualizations. You can go ahead and take a look at them if you want to know more about QuickSight. And be sure to try different data combinations of your type to understand QuickSight a little better. So go ahead and download different data sets and try creating different data visualizations. You'll be able to understand QuickSight practically. So that's it, guys. I hope the session was informative. And if you have any doubts or any queries, you can post them in the comment section below. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
Amazon Web Service, or AWS as we know it, is one of the world's most popular and reliable cloud computing platform. It includes a wide range of compute services using which we can host simple websites as well as complex applications. Hey guys, I'm Archana from Edureka and I welcome you to the session on Amazon Lightsail. So let's get started by taking a look at topics which we'll be discussing today. We will begin by having a brief discussion on AWS compute services. Then we'll take a look at Amazon Lightsail, a compute service offered by Amazon. Once we know what Lightsail is, we'll try to understand who uses this Lightsail and for what reasons. And finally, we'll explore different key features of Amazon Lightsail by deploying a WordPress blog. So let's get started. Building and running your organization starts with compute. Whether you're building a huge enterprise or a simple mobile app, the term compute refers to activities or workloads that require a great deal of computation. Amazon offers plenty of these compute services using which you can deploy, develop, run, and scale your applications in a secure way. So let's take a look at few of these compute services. First, we have Amazon EC2. As you already know, Amazon EC2 is one of the most powerful compute service offered by Amazon. Suppose you want to deploy an application, but you want the freedom to select the underlying infrastructure, as in the operating system on which you want to host your application, or the amount of storage that you want to attach to your application, or the network details like security groups and firewalls, then Amazon EC2 is the best choice. So in simple terms, Amazon EC2 is a web-based service using which you can run your application programs on a bare virtual machine. Then we have Amazon Container Service. The concept of containerization is currently in trend today. Containerization basically is a method using which you can deploy and run your applications without launching entire virtual machine. The container has everything you need to start your application like libraries, codes, and system tools. So Amazon provides you with one such tool, which we call Amazon Elastic Container Service. Using this service, you can run and scale containerized applications on AWS Cloud. And then we have AWS Lambda. Lambda, as it turns out, is a framework of EC2 container service that runs a single piece of code or application. So with AWS Lambda, you just have to run the code. The resources required to run and scale your code will be automatically handled by AWS Lambda service. So in simple terms, AWS Lambda is a serverless computing platform which lets you build and run your applications without worrying about underlying server infrastructure. And finally, we have Amazon Lightsail, which is topic of discussion today. Well, for starters, it's the easiest way to launch and manage a virtual private server in AWS Cloud. So to understand what I mean by that, let's go ahead and explore Amazon Lightsail in detail. So before we dig in, let's take a look at the scenario. Let's say you have decided to get a dream home for yourself. Based on the type of person you are, there are two possibilities. Suppose you're a meticulous planner and you love planning things. The first thing you do when you decide to buy a home for yourself is you do research. You research on the type of homes that are available in the market. You research until you find the one you like. Once you're done with your thorough research, you start planning. You start deciding on interior designing of your house. You start deciding about the type of garden you want, or the type of kitchen you want, or how you want your house to look at. So once you're done with your research and planning, you hire people to execute this plan. So in simple terms, on your journey to build a dream house, you make a lot of big decisions. Alternatively, let's say you're someone who finds this do-it-yourself approach a waste of time. You're just interested in the final results without having to make any decisions along the way. So you go ahead and buy a house of your choice which is already furnished. As you know, this doesn't involve any kind of planning or research. The concept of Lightsail is very similar to this scenario. Let's say you want to build an application and you've chosen Amazon EC2 as your platform. As you already know, when you're trying to launch an Amazon EC2 instance, you have the freedom to decide the underlying infrastructure. You handpick the individual AWS components like storage, server, security groups, IP address, VPCs, and many other components. Once you've chosen all the components you need, you put them together and host your application. Well, that is one way. But if you simply need a system that's pre-configured and pre-assembled, as in you just want to run your application on a built-in platform, the best option would be virtual private server. So with virtual private server, you have a handful of options. You have fixed storage, you have fixed network configurations, you have fixed infrastructure stack. Since all these components are already provided by virtual private server, you can concentrate on developing code for your application. But the problem with virtual private server is if later on, if you want to expand your application, you find that in virtual private server, the options for scaling are very limited. This is where Amazon Lightsail comes into picture. Amazon Lightsail is very similar to virtual private server, but unlike virtual private server, it provides you with an option to auto scale. So you get simplicity of VPS, backed up by reliability and security of AWS. As your need grows, you will have option to auto-scale and connect other AWS resources like database and SNS services if needed. So with Amazon Lightsail, you can run a simple application. You don't have to bother about the underlying infrastructure, and you have an option to auto-scale resources according to your application need. If I have to define Amazon Lightsail in a single sentence, Amazon Lightsail is a virtual service that's cost-effective, fast, and reliable with an easy-to-use interface. So now you know what Amazon Lightsail is. But the question here is, when we have so many other compute services, why use Lightsail? Lightsail is best choice for developer if he wants to spend his time in application rather than deciding the underlying infrastructure. Also, if you're someone who are trying to understand the cloud concepts such as virtual machine, storage, network, and all these details for the first time, then Lightsail is the best option. So Amazon Lightsail provides you with everything you need to jumpstart your application. Well, to begin with, it provides a virtual private server that you can launch within just few clicks. And you don't have to worry about underlying infrastructure like network and storage. Well, you have two options. You can create an instance image with just base operating system, or you can create an instance image with application or development stack along with base operating system. Well, if you're not understanding what I'm saying here, you'll understand it perfectly when we deal with it in the demo part of the session, so don't worry. Moving on, suppose you want your application to integrate with other external application, or you want to extend your application, then Amazon Lightsail provides you with a simple and flexible API, that is Application Programming Interface. It also provides you with highly available storage. So with Amazon Lightsail, we have high performance storage in form of SSD blocks. And the storage is highly available, it's easy to manage, it's scalable and very secure. Amazon Lightsail also provides you with speed and secure networking connections. When you try to launch an Amazon Lightsail instance, all the network configurations are taken care by Amazon Lightsail in the background. But later on, if you want to make any changes to this network configurations, you can go ahead and do that. Amazon Lightsail provides you with an option where you can change the security groups, assign rules, and you can even deal with DNS as well. And suppose your application needs additional features like managed database, content delivery network, or any other features, you can connect to other additional AWS services using Amazon Lightsail VPC Peering option. I'll show that to you as well in the demo part of the session. And finally, we have load balancing. Let's say your application is handling a lot of traffic, and because of which, the performance of your application is going down tremendously. So you can enable load balancing, because of which the load that your application receives is equally distributed among different instances, and therefore the performance of your application grows. So to summarize all that we've learned till now, Amazon Lightsail is very fast and easy to use. It's fast because, like I said earlier, with just few clicks you can launch a VPS. And it's easy because the Amazon Lightsail console is made in such a way that even the beginner would easily understand and will be able to use it. And the second thing, Amazon Lightsail grows with you. As in, later on, if your application needs additional resources, then Amazon Lightsail provides you with an option to auto-scale. And the best part about Amazon Lightsail is its pricing plans. I'll try to explain you the different pricing plans in the demo part of the session. So for now, let's skip that part. And finally, Amazon Lightsail provides you with 1 month free usage. Suppose you are here just to explore what Amazon Lightsail actually is and what you can do using Amazon Lightsail, or say you just want to host a simple application or website using Amazon Lightsail, then you can make use of this free month usage provided by Lightsail. And if you like it, you can continue using it, as the pricing plans provided by Lightsail are really the best. So guys, that was all about the theory part of the session. Now let's try to deploy a WordPress website using Amazon Lightsail. But I'll have to let you know something. The purpose of this demo is not just to deploy a WordPress website, but to understand different features we discussed earlier of Amazon Lightsail. So let's go ahead and do that. So guys, this is my AWS management console. And as you can see, there are quite a lot of services. We have compute services, storage services, media services, analytics services, and mobile services, and many others. And within compute services, we have many as well. We have EC2, we have Lightsail, Container Service, Lambda, and Elastic Beanstalk. And if I'm just a beginner in this AWS cloud technology, the number of services when I see here might become a little too much for me. So I'm going to choose this Amazon Lightsail here. So it takes me to Amazon Lightsail console page. As you can see, this console, or the Amazon Lightsail console, is very simple compared to my AWS management console. I have very few options here. I have instances where I can create different type of instances. Then I have networking, storage, and then snapshots. So just 4 options. So let's start with a demo. I have an option which says create instance. I want to click on that. And the first thing is I'll have to choose the region and availability zone. So let's say I'm going to choose Mumbai here. And based on the region I chose, the availability zone varies. We'll have Zone A and Zone B in Mumbai region. I'm going to pick Zone A. And then comes the OS part. As you can see, we have different blueprints of applications and operating system. As for the operating system, we have 2, Linux and Microsoft. And like I said earlier, you can create an instance image with just base operating system, or you can create an instance image with application or development stack along with base operating system. So let's say I've chosen Linux. As for the OS part, I have different Linux distributions here. I have Amazon Linux, I have Ubuntu, Debian, and many others. And as for the application part, I have WordPress, LambStack, Nginx, GitLab, and many others. Then going to Microsoft Windows, as for the OS part, we have Windows Server 2016 and 2011. And the application part, I have SQL Server with Windows as a base operating system. For the purpose of this demo, I'm going to choose WordPress app with Linux as base OS. And suppose you want to know all the information there is regarding all these applications and operating systems, you have a link which says AWS Marketplace. You can go there and verify the information. And when I scroll down, suppose you want an action to take place when you launch your instance for the first time, you can add the script here. And just like in Amazon EC2, when we launch an instance, we create or we generate a key pair. Similarly, we have an option where we can create a new pair or upload one if you have one already. And but the best thing with Amazon Lightsail is it provides a default key. So I'm going to use default key for this demo. Moving on, we have pricing plans here. The best thing about Amazon Lightsail, if you search in the documentation part of Amazon Lightsail, it says that they have no nonsense planning, and it's according to their word. Well, as for the Mumbai region, the basic plan starts with $3.5. Every Lightsail plan has a fixed amount of memory, as in RAM, and compute resources like virtual CPUs, and then the storage disk in the form of SSD blocks, and then the data transfer rate. Well, if you look at the first plan, it says $3.5. As for the memory, it's 512 MB. And for the compute resources, 1 virtual CPU. And then we have 20 GB SSD storage. And the transfer rate is about 512 GB. Then when you go for the next plan, the transfer rate is 1 TB, 1.5 TB, 2 TB, and it varies. So this data transfer rate is basically refers to the amount of data you transfer from your Lightsail instance to other Lightsail instance or other AWS instances. So if you try to transfer data, the amount of data is within this 512 GB, then the data transfer rate is free. But the moment it goes above this 512 GB, you will have to pay the cost. But one thing is, in data transfer, you have data in and data out, as in the data that you receive from other AWS resources or other Lightsail instances, it's always free. But for the data out part, if you're trying to transfer data from your device to other devices, then if it's within 512 GB, then it's free. Otherwise, you'll have to pay, as I said earlier, as in you have to incur other extra cost. And then moving on, it asks for a name when you can give the name of your choice. And you have the number of instances you want of same type. Well, you can choose 2, 3 according to your choice. But for this demo, I'm just choosing 1. And the single option, I'm going to click on this create. Like I said earlier, with just one click, I launched a virtual private server here. So like I said earlier, the purpose of this demo is to explore different features of Amazon Lightsail. And I'm going to do just that. Okay, so the WordPress is being deployed in the background. Tasks like creating virtual private server, security groups, assigning rules to the security groups, and setting up storage, etc. will be done by the Lightsail in the background. So let's give it a few seconds to finish and move on to our next step. So it's done. And I'm going to click on this. And the first thing you see is you have 2 options. You can stop the instance or reboot it. And then you have private IP address and public IP. The point is this public IP keeps changing every time I launch this instance. So the one solution for that is to assign a static IP. And we'll see how to do that in the later part. Let's go ahead and explore a few other details. So I have an option which says connect using SSH. This Amazon Lightsail provides you with a default terminal using which you can launch your instance. And suppose if you want to launch this instance using your own terminal, then you have the IP address and the username here, and you need a key if you remember. So when I click on this page, it takes me to a page where I can find the key to launch an instance on my terminal. All I have to do is just download this. Okay, then going back, I'm going to go to my console, Amazon Lightsail console, and in the networking part, I have a create static IP option. So I'm going to choose an instance for which I want to attach the static IP. And as you can see, this IP has a name and click on create. When I go back to my instance, you can see that in place of public IP, we have static IP. So suppose you relaunch your instance later, this IP address won't change. So let's go ahead and launch this instance. Suppose you want to view this WordPress blog on your browser. All you have to do is copy this IP address. The same thing. I'm just going to copy this and paste it in the browser. So as you can see, it's as easy as that. With just one click, I've deployed a WordPress website. And when I scroll down, I have a login option here, but I need username and password to log in. As you can see in the right corner, I have a Bitnami image. When I click on that, it takes me to a page where I can get my username. But as for the password, we have to launch an instance. So I have this option which says connect using SSH. I'm going to click on that. So the default terminal provided by AWS opens. Well, I've successfully launched. I have a file called Bitnami application password file where the password is stored. Okay, so as you can see, this is a password. I'll have to copy that. So in the right corner, you see an option. I click on that. I'm going to select this data. Well, this is kind of text editor. I'm going to select this password from here, copy. And as for the username, we already know which is user. So let's go ahead and log in. User. And as for the password, we just copied it. I'm going to paste it here and then click on login. So I've successfully logged into my WordPress page. And now if I want to post some new blogs or anything, I can go ahead and do that. Suppose let's do that. So I have add new. So I have this poem. I'm going to attach that here. For the media part, it's there in the downloads. It should be in the first itself. So it's here. Open into the post and a little bit editing. Let's say full size. Update and publish. So let's go and take a look at the preview. So as you can see, before it was in there, I just posted a new blog. So that's it. It's very easy. And then let's go back and explore other features. Okay, now that we've used default terminal to launch an instance, let's go ahead and use other terminal. Well, I have this Git terminal on my PC. Well, here. So cd, I need to come out from the desktop part. Then using SSH option, I need to connect to my instance. Okay. Before that, I need to download the key. Okay, I have this link here. And since I'm using default key, I have a download option here. It's downloaded. Let me go back to downloads and check if it's there. So this is it. This is the key. I'm going to rename it so that I can access very easily. Let's say SSH key. That's it. Let's see if it's stored as a .pem file. Properties. As you can see, it's stored as a PM file. Okay, then let's go back to our terminal. Here, SSH key. So .pem. Was the name right? Let me check back. SSHK. SHK.pm. And as for the IP address, and here you can see a username. Since WordPress is Bitnami application, I have to use Bitnami as in my username. Suppose if you're launching some AWS instance, you have EC2 user as your username. Here I have to copy the IP address of my instance. So let's go back. This is the IP. I'm just going to copy it and paste it over there. It should work. Yes. So as you can see, I've successfully connected to my Amazon Lightsail instance from my own terminal. Okay, we have done that. Going back for the storage part. And suppose you just started with a basic application, but later on you've expanded your application and you need additional storage. So you have an option where you can create or add new disks. Well, this is the disk or the storage which has been assigned to my application when I chose the plan. Then I have metrics part. Just like you have Amazon CloudWatch in the AWS Management Console, you have a default monitoring tool here. It shows all the CPU utilization, network details, and you have status check as well. Moving on, as for the network part, as you can see, I've assigned a static IP, so it's been showing here. And then I have private IP address. If you remember, all the security groups are by default launched by Amazon Lightsail when I launch an instance. So I have all the security groups. And if I want to customize this, I can go ahead and add new security groups. If I want to assign new rules to the security groups, I have an option here as well. And then suppose if my application is handling a lot of requests and I want to distribute the traffic, to make my application performance great, then I have an option. I can just enable this load balancing. And for the snapshots, okay, so here are the concept. Like the pricing concept is Amazon Lightsail and Amazon EC2 is mostly similar, as in you'll be cost according to the hour usage. But the problem in Amazon Lightsail is if your instance is not running, as in it's just stopped, even then you'll have to pay. So you have to stop your instance or create a snapshot of your instance and delete the instance. Only then you won't be cost and you don't have to pay the extra cost. But if you remember in Amazon EC2, you will have to pay only if your instance is running. If your instance is stopped, then you don't have to pay. So that is where the concept of snapshot comes into picture. You can take a snapshot of your instance and you can delete your instance. In the later on, if you want the same instance with same features, then you can use the snapshots to create an instance. We'll see that later. Then as for the history part, it's just a list of events that has been occurring since the time you've launched your instance. As for this instance, I've created it and then attached the static IP. That's what it shows here. Then delete with just one click, you can delete an instance. So let's go back to management console. We have explored everything there is regarding our instance. Then going for the networking part, you have an option to create static IP, which we already did. Then you have DNS zone. Suppose you just don't want to refer to your instance using the IP address, you want to give it a proper name, then you can use this DNS zone. Then we already have touched the load balancer concept. Then I have storage thing. Similarly, if my application needs additional resources, I can go ahead and create a disk and attach it to my instance. And we have discussed the snapshot as well. So that's about in the Amazon Lightsail console. Well, for the account part, let's go and explore. I have profile, which is similar to my AWS profile. Then I have SSH keys, which we already discussed earlier. As for this demo, I've used default key, but if you want to go and create your own key, you can do that, or you can add an already existing key as well. And then for the advanced details, well, suppose you want to extend your application or you want to integrate your application with other applications, then you have API. It's very simple and user-friendly. And suppose you want to interact with other AWS services. Earlier in the theory part, I mentioned that you have something called VPC Peering. All you have to do is click on this enable VPC peering, like whichever the region you want. All the underlying details will be thoroughly handled by Amazon Lightsail. So that's it. As I've already said, the purpose of this demo was just not to launch a WordPress website. I've used it as a means to explore all the features. I hope you're clear with Amazon Lightsail console and all the features and all that. So go ahead and explore it. Try to create new instances, new SSH keys, attach storage as well. So that is it, guys. I hope the session was informative and demo was fun. Well, if you have any doubts or comments, you can post them in the comment section below. And thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
With digital data growing at incomprehensible rate, enterprises are finding it difficult to ingest, store, and analyze data quickly while keeping their costs low. And therefore, they're moving their data warehouses to cloud. Hey guys, I'm Archana from Edureka, and in this session, we will be discussing about Amazon Redshift, the most popular cloud-based data warehouse. So let me run you through today's agenda quickly. We will begin by taking a look at traditional data warehouse. We'll be discussing its underlying architecture and the disadvantages of using traditional data warehouse. And then we'll move on to our today's topic, which is Amazon Redshift. Here, we'll be discussing its architecture, its key concepts, its unique features, and the advantages of using Amazon Redshift. And finally, we'll be doing a demo on Amazon Redshift. In this demo, we'll see how to import data from Amazon S3 to Amazon Redshift and perform queries on this data very easily. So I hope that was clear to you guys. Let's get started. I'm sure you know what a data warehouse is. You can think of data warehouse as a repository where data generated from your organization's operational systems and many other external sources is collected, transformed, and then stored. You can host this data warehouse on your organization's mainframe server or on cloud. But these days, companies are increasingly moving towards cloud-based data warehouses instead of traditional on-premise systems. And to know why, we need to understand the underlying architecture and the disadvantages of using traditional data warehouses. So let's begin by looking at architecture part. It is important to understand where the data comes from. Traditionally, data sources are divided into two groups. First, we have internal data, that is, the data which is being generated and consolidated from different departments within your organization. And then we have external data, that is, the data which is not getting generated in your organization. In other words, that is the data which is coming from external sources. So this traditional data warehouse follows a simple three-tier architecture. To begin with, we have bottom tier. In bottom tier, we have a warehouse database server, or you can say a relational database system. In this tier, using different kind of backend tools and utilities, we extract data from different sources and then cleanse the data and transform it before loading it into data warehouse. And then comes the middle tier. In middle tier, we have OLAP server. OLAP is an acronym for Online Analytical Processing. This OLAP performs multidimensional analysis of business data and transforms the data into a format such that we can perform complex calculations, trend analysis, and data modeling on this data very comfortably. Finally, we have top tier. This top tier is like a front-end client layer. This tier holds different kind of query and reporting tools using which the client applications can perform data analysis, query reporting, and data mining. So to summarize what we have learned till now, traditional data warehouse as a simple three-tier architecture. In the bottom tier, we have backend tools using which we collect and cleanse the data. And then in middle tier, we have tools, which is OLAP server, using which we transform the data into the way we want. And then finally, top tier, in which using different query and reporting tools, we can perform data analysis and data mining. Moving on to the disadvantages of traditional data warehouse concept, there is this leading US business service company, and this company is running a commercial enterprise data warehouse. This data warehouse has data coming from different sources across different regions. The first problem that this company faced was when it was setting up a traditional data warehouse. As we discussed earlier, the architecture of traditional data warehouse is not very simple. It consists of data models, extract, transform, and load processes, which we call ETL, and you have BI tools sitting on top. So this US-based company had to spend a lot of money and resources to set up a traditional data warehouse. Data warehouse, which was initially 5 terabytes, was growing over 20% year over year, and it was expected that there might be higher growth in future. So to meet this continuously increasing storage and compute needs, the company had to continuously keep upgrading the hardware. Again, this task of upgrading the hardware continuously involves a lot of money, manpower, and too many resources. So, autoscaling in traditional data warehouse is not an easy concept. And since the company could not meet all the storage and compute needs easily, it was facing a lot of performance issues as well. And finally, the company had to deal with increasing costs. Initially, they had to spend a lot on setting up data warehouse, like that to spend on hardware, manpower, electricity, security, real estate, and deployment costs, and many other. And as their data warehouse grew, they had to spend again to meet storage and compute needs. So to sum it up, setting up a data warehouse and deploying it and managing it later involves a lot of money and resources. Moreover, autoscaling in traditional data warehouse is not an easy concept. Because of all these reasons, many companies are increasingly moving towards cloud-based warehouses instead of traditional on-premise systems. So guys, in this session, we'll be dealing with one of the most famous cloud-based data warehouse provided by Amazon, which is Amazon Redshift. In simple words, Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost-effective for you to analyze all your data across your data warehouse and data lake. Guys, I have a definition which is put up on the screen, and I have few words which I have highlighted over there. So as we progress through the course of this session, we'll know what those words exactly mean. So let's ignore them for now. But there are certain key concepts which you should be aware of when you're dealing with Amazon Redshift. So we'll discuss them now. Amazon Redshift DataWare is a collection of compute resources which we call nodes. And these nodes, when organized into a group, they become clusters. Each of these clusters run an Amazon Redshift engine, and it contains one or more databases. So this cluster has a leader node and one or more compute nodes. As for the leader node, it receives queries from client applications and then it passes these queries and develops a suitable query execution plan. And then it coordinates the parallel execution of these plans with one or more compute nodes. Once the compute nodes finish executing this plan, again the leader node aggregates the results from all these intermediate compute nodes and then sends it back to client application. Then we have compute nodes. You can think of these compute nodes as a compute resources that execute the query plan which was developed by leader node. And when they are executing this plan, they transmit data among themselves to solve many queries. These compute nodes are further divided into slices, which we call node slices. Each of these node slices receive part of memory and disk space. So the leader node distributes data and part of user query that it receives from client application to these node slices. And all these node slices work in parallel to perform operation and increase the performance of your Redshift data warehouse. So to say, we have leader node, we have compute nodes and node slices. But how do they interact with client application? That is the question here. So I have these client applications, basically BI tools or it can be any other analytical tools, which communicate with Amazon Redshift using drivers like JDBC and ODBC. JDBC refers to Java Database Connectivity Driver. It is an API for programming language Java. Then we have ODBC. It refers to other database connectivity driver and it uses SQL to interact with leader node. So basically using these drivers, client application sends a query to leader node. Leader node on receiving the client application's queries, it passes these queries and develops a suitable execution plan. Once the plan is set up, compute nodes and compute slices start working on this plan. They transmit data among themselves to solve these queries. So once the execution is done, leader node again aggregates the results from all these intermediate nodes and sends it back to client application. So this is the simple explanation of Amazon Redshift concepts. Moving on, when you launch a cluster, you need to specify the node type. Basically, we have two types of nodes. Dense storage nodes. These are storage optimized and are used to handle huge data workloads. And basically, they use hard disk drive or HDD type of storage. And then we have dense compute. These dense compute nodes are compute optimized and they are used to handle high performance intensive workloads. And they mainly use solid state drive or SSD kind of storage. But there are three things that you should keep in mind when choosing one among them. Firstly, you should be aware of the amount of data that you want to import into your Amazon Redshift. And then the complexity of the queries that you run on your database. And the need of downstream systems that depends on the results of these queries. So keeping these three things in mind, you can choose either dense storage nodes or dense compute nodes. So guys, that was the architecture and its key concepts. Now we'll take a look at few reasons as to why Amazon Redshift is very popular. As we discussed earlier, setting up a traditional data warehouse involves a lot of money and resources. But it's very easy to set up, deploy, and manage a suitable data warehouse using Amazon Redshift. On Amazon Redshift console, you will find Create a Cluster option. When you click on that option, Amazon Redshift asks you for certain details like the type of node you want to choose, the number of nodes, the VPC in which you want to create your data warehouse, user ID, password, and many other details. Once you feel that you have given the right set of details, you have an option which says Launch the cluster. And one click, your data warehouse is just created. So with one click, you can easily create a data warehouse in Amazon Redshift. Once your data warehouse is set up, Amazon Redshift automates most of the common administrative tasks like managing, monitoring, and scaling your database. So you don't have to worry about managing or scaling your database needs. So that's how easy it is to develop or set up a data warehouse using Amazon Redshift. We also learned that auto-scaling is difficult in traditional data warehouse, but you can scale quickly to meet your needs in Amazon Redshift. Well, we already know that a cluster node has a leader node and one or more compute nodes. So if you want to auto-scale in Amazon Redshift, all you have to do is resize your cluster size. As we know, these compute nodes are like compute resources. So if you want to scale up, you can increase the number of compute nodes. Similarly, if you want to scale down, you just have to decrease the amount of compute nodes. Alternatively, we have something called single node and multiple node. In single node cluster, one node takes the responsibilities of both leader and compute functionalities. And the multi-node cluster contains one leader node and user-specified number of compute nodes. So suppose you want to resize your cluster and you are using a single node cluster, then you can change from single node cluster to multi-node cluster. Similarly, you can change from multiple node cluster to single node cluster when needed. So that's how easy it is to scale up and down in Amazon Redshift. Moving on, we learned earlier that while using traditional data warehouses, it's possible that the performance of your data warehouse might decrease. But with Amazon Redshift, you can get 10 times better performance than any other traditional data warehouse. It uses a combination of different strategies like columnar storage and massively parallel processing strategies to deliver high throughput and response times. So let's discuss these strategies one by one. Well, first we have columnar data storage. To understand what that is, first we should know row storage. Most of the traditional data warehouse and databases use this row storage. In row storage, all the data about a record is stored in one row. Okay, so let's say I have this database here. I have 3 columns and 2 rows. The first column contains the unique number associated with student. The second column contains the name of a student, and the third column contains the age. As we already know, data is stored in form of blocks in databases or data warehouses. So as you can see in row storage, the block 1 contains all information there is about a particular student, his SSN, his name, and then age. So basically it stores all the information that there is in a single row. So in the first block you have information about first student, and in the second block you have information about second student, and it goes on. Now the columnar storage. Again I'm using the same database. Again I have 3 columns and 2 rows. But column storage stores data by columns, with data for each column stored together. So again we have blocks, but the first block here has all the data that is there in first column. So you have all the SSN stored in first block, and all names stored in second block, and all the ages stored in third block. So it goes on. There are a lot of advantages of using this column storage. Firstly, since in column storage a single block contains same type of data, you can achieve better data compression. As you can see, columnar storage can hold values 3 times the records as row-based storage. Because of this, the number of input-output operations decreases. And thirdly, by storing all the records for one field together, columnar database can query and perform analysis on similar type of data far quicker than row storage. So this is how the concept of columnar storage, which is used by Amazon Redshift, provides us a better performance. And then we have massively parallel processing. I'm sure you might have heard of parallel processing in computer science. It's just that number of different processors work together or compute together or in parallel. Similarly, massive parallel processing in Amazon Redshift is nothing but clustering. We have already discussed this earlier. We have a cluster, and this cluster has a leader node and one or more compute nodes. And this compute nodes is further divided into something called node slices. So when this leader node receives a query, it develops an execution plan, and this compute nodes and compute slices work together or in parallel to execute this plan. And later, this leader node sends the results back to client application. So basically, this compute slices and compute nodes work in parallel to achieve better performance. Moreover, Amazon Redshift is also able to smartly recognize the data on nodes before running a query, which dramatically boosts the performance. So that's how we can get a 10 times better performance using Amazon Redshift. And then the cost. In traditional data warehouses, people had to spend a lot of money to set up and then later to maintain the data warehouse. But Amazon Redshift is the most cost-effective cloud-based data warehouse. If you remember, in traditional data warehouse, they had to spend on hardware, real estate, manpower, electricity, and deployment cost and many others. And as their data warehouse grew, they had to spend again on meeting the storage and compute needs. But in Amazon Redshift, we don't have to pay any upfront cost. So Amazon Redshift is most cost effective, and it costs 1/10 of traditional data warehouse. You can start small for just $0.25 per hour without any commitments, and you can gradually scale up later if you need. In addition to all those advantages, Amazon Redshift allows you to query data from Data Lake. Data Lake is a storage repository that holds a vast amount of raw data in its native format until it is needed. So in Data Lake, you have data in different formats. You can load data from Amazon S3 into your Amazon Redshift cluster for analysis very easily. That is, from Data Lake, you can store easily into your Amazon Redshift. But it needs more effort and cost. Effort because loading data into Amazon Redshift cluster involves extract, transform, and load, which we simply call ETL process. And this process is very time consuming and compute intensive. And it's costly because uploading lots of data, cold data from Amazon S3 for analysis requires growing your clusters, which is again costly and requires a lot of resources. So as a solution, we have something called Amazon Redshift Spectrum, which acts as an interface between your Amazon S3 or data lake and Amazon Redshift. So you can directly query data stored in Amazon S3 or data lake with this Redshift Spectrum without need for unnecessary data movement. I hope that was clear. And finally, with Amazon Redshift, your data is safe and secure. It offers backup and recovery. So as soon as data is created or stored in Amazon Redshift, a copy of that data is made, and through secure connections, a snapshot of it is sent to Amazon S3 for later. So suppose you lose your data, or if you have deleted the data from Amazon Redshift by mistake, you can restore the data easily from Amazon S3 service. Amazon Redshift also provides you with an option to encrypt your data. So when you enable this encrypt option, all the data in your cluster, in your leader node and your compute nodes and node slices is encrypted, and this way your data is very safe and secure. So guys, these are all the advantages of using Amazon Redshift. So now you have a basic idea of its architecture, its various key concepts like clusters, nodes, leader node, node slices. Now it's time to work on a demo. In this demo, we'll see how to transport data from Amazon S3 to Amazon Redshift Data Warehouse and perform simple queries. So I hope that was clear to you guys. Let's get started. But the first thing, there are certain softwares which you need to pre-install so that you can start working on Amazon Redshift. First, suppose you want to perform queries on the data on Amazon Redshift, then you need a SQL workbench where you can perform your queries. And as we learned earlier, the client application need a connection to communicate with Redshift. So we need to install a JDBC driver. And for that JDBC driver to run, we need to have a Java runtime environment. So we have three things to install here now. I'll show you how to install each of them. And I have this Java runtime environment download link by softonic.com. So it says free download and you click on that, it'll be downloaded. You can store it anywhere. And once you're done with that, search for Amazon Redshift documentation. So here it is. Okay, not that. This one. And when you scroll down, it says Amazon Redshift get started. Click on that. And in the step 1, we have prerequisites. Okay. Scroll down and it says in the step 2, you have an option where you can download or go to SQL Workbench website and download it. So click on that. And here it says build current version. And you have download generic packages for all systems. You can download it. Once you click on that, it'll start downloading. And there is one more thing, which is JDBC driver. Go back to documentation part. Scroll down and the step 4, you can see configure a JDBC connection. Click on that. It'll take you to a page where you have JDBC drivers of different version. You can download the first one. Click on this and it'll be downloaded. So once all these three things are downloaded, store them in a file of your choice. Well, I have stored them on my desktop. I have this AWS folder and in that Redshift. So here's my workbench, a zip file. It was a zip file, so I extracted all the files. And then I have my JDBC driver here. Well, Java runtime environment isn't download, so that's okay. So I hope that was easy. So just install all these things and you're set to go. And we're back to our Amazon Management Console. I have previously used Amazon Redshift, so I have this Amazon Redshift in recently visited services. Anyway, you can search for Amazon Redshift here. Here it is. Well, it's taking time to load. Okay, this is my Amazon Redshift console page. And you have different kind of options on your navigation pane on the left side. And there are two ways to create or launch a cluster. First, you have quick launch cluster option and launch cluster option. This is the very easy way to launch a cluster. But suppose you want the freedom to specify all the details as in the VPCs, the security groups, different type of nodes, username, password, and all that, you can go for launch cluster option. Let's go ahead and explore that. So first it asks for a name, let's say my cluster, and database, DT1, and the port, this is default port, 5439 is the default port which will be handled by Amazon Redshift. Then the master username, let's say AWS user, and password. That's it. And confirm your password and click on continue option. So cluster details are done and dusted. Then you have node configurations. Well, for the free tier, you only have DC2 large. But suppose you have a premium membership, then you can choose any of this. For this DC2 large, this is the CPU capacity, memory, and storage. And the input-output performance is moderate. You can go ahead and choose the cluster type. We discussed this. We have multi-node and single node. In single node, we have both the leader and the compute node responsibilities handled by single node. The multi-node, we have a single leader node and user-specified number of compute nodes. Click on continue. And then here it asks for the VPC details, parameter group, and suppose you want encryption or not, and all the details. So basically, in this launch cluster option, you have the freedom to specify all the details. But for this demo, I'm going to use quick launch cluster option. So again, as for the free tier, I'm using DC2 large. And again, for the free tier, I'm using DC2 large type. It says there are 2 compute nodes. And let's retain the same cluster name. As for the master user, AWS user, now let me give the password. And the default port is 5439. And last option, we have to choose among the available IAM users or IAM roles. But the question is why we need an IAM role here. In this demo, I said that we're trying to import data from Amazon S3. But you need certain set of permissions to access data which is stored in Amazon S3. For that, we need to create an IAM role. So let's go back to IAM service. Let me close all these tabs. Okay. Here you have roles option. You can click on that and click create role. And since we're dealing with Amazon Redshift, select Redshift, Redshift customizable, and click on next permissions. So we want Amazon Redshift to access data from Amazon S3. So search for S3 here. And you have a permission which says Amazon S3 read-only access. Well, for this demo, this is an if, but there is one more permission which says Amazon S3 full access. So you can perform read and write operations as well. As for this demo, I'm going to choose this permission which says Amazon S3 read-only access provides read-only access to all the buckets in Amazon S3. And click on next review. Give your role a name. Let's say my Redshift role 2 and click on create role. So now our Amazon Redshift database has permission to access data from Amazon S3. Let's go back to Redshift console. Okay, let me refresh this. And now it's showing the role which has been created is showing here. So as you can see, unlike other launch option in this, I didn't have to specify much details, just the node type, the number of nodes, and then the master username, cluster identifier, and password, and the default database port. And you can click on launch cluster option. So with one click, you've easily deployed a database on Amazon Redshift. If you remember, when we tried to use this launch cluster option, we had option to select a default database or create our own database. But when you use this quick launch cluster option, a default database called dev will be created for us. So guys, this cluster has been created. So before we connect it to your SQL workbench, let's try to explore here. You need to make sure that the database health status and in maintenance status, everything is in green color. As for the cluster status, it should be available. And for the database health, it should be healthy. Only then you can make a perfect connection with your SQL workbench. So you have this icon here, click on that. Well, you get all the information there is about your cluster, or you can just go ahead and click on this cluster. So this is the endpoint. This tells me all about how to make a connection with this cluster. I have this. When I click on that, it says publicly accessible, yes. And the username is AWS user. And the security groups, apparently it just shows the TCP rules which are set. So that's about the endpoint. Then the cluster name, you have cluster type, node type, and it shows the nodes and the zone and the date and time when it was created. And you have cluster version as well. On the right side, you have cluster status, which is available, database health healthy. So is it currently in maintenance mode? No. And then you have parameter group apply status, which is in sync with your database. And there are a few other features as well. But here you can see this VPC group. Click on that. Go for inbound and make sure it is set for TCP. Okay, edit. Make this custom TCP rule. And here 5439. Custom. That's it. And click on save option. So that's the default port with which you can access the Redshift. And let's go back. Clusters. Okay, where were we? We changed the default group of VPC. So this is the URL with which you can connect to the SQL workbench. So let's copy this and paste it in our text file. I've pasted it over there. Well, if you're using ODBC connection, then you can use this URL. When you scroll down, you have capacity details of your entire cluster. It's DC2 large. So 7 EC2 compute units, total memory, storage, and platform. Okay, let's go back to this IAM role, but I should have an IAM role option here. Let me see, check it out. Okay, there's an option which says see IAM roles. You can copy this entire thing and paste it again in the editor so that while connecting it, it'll be easy for us to find it. Okay, then so now your cluster is created, your database or data warehouse is set up. Now you can just connect it with SQL Workbench and start working on it. So let's go back to the folder where I've stored my Workbench. Here it is. When you scroll down, there's a file which says SQL Workbench executable jar file. Open. So here it is. It's asking for a default profile name. Let's say new profile 1. Okay, then driver, that was Amazon Redshift driver only, JDBC driver. And this was the URL. We copied it earlier in the editor, so I'm going to paste it over here now. This is the URL. Control C and paste it. AWS user in the password. Okay, that should work. Make sure that you select this auto commit, save it, and then click on OK. It says connecting to the database. Now it's successfully connected. So I can easily perform queries now. First, let's create some tables. Well, I'm using the sample database from Amazon S3. So you have this AWS Redshift documentation. Go back to that. And here it says get started. And in the step 6, you have this default SQL queries and tables provided. So you can go ahead and use that. I have it stored in my editor. So I'm going to copy. First, I'm going to create all the tables. Control C and paste it over there. Let's check what tables are there. First, we have user table. Well, this is like an auction data schema. So you have user table, many users, and you have category users, the category, different categories to which users belong to. And then you have date on which a particular event occurred. Then you have event table, all the details regarding an event. Listing, as in the items which are being sold are listed here, all the details about the items. Then you have sales, as in which user is buying, how much, which item, and all that details. So basically we have 6 to 7 tables. I'm going to select all that and say run option. So here it says table users created, table venue created, category, date, event, listing, and sales. So all the tables are easily created now. As for the next part, we need to copy the data or the data for the database from Amazon S3 to Amazon Redshift. Let's go back to the editor. And I have this copy command. I'll explain you the format. Control C. And let's paste it here. Okay, let's explore this copy command. It says copy to the table users which you just created from this path. That is from the file which is stored in S3 bucket. But this is the credentials AWS IAM role which we copied to the editor earlier. Apparently, we're just giving a permission to access the data from S3. So we need to copy this IAM role here. And then we have delimiter. As in, let me go back to editor and show you an example. Okay. Let's say I have a data. Let's say I have name, Archana, space, some age, D, hobbies. So you can see this straight line. This is the delimiter, as in the thing which you're using to separate all the fields or the columns. So going back. So that's delimiter which separates the data. And this is region in which your S3 bucket is located. So that's it. But we have to replace the IAM role. This is the ARN of the role. I'm going to copy it. And wherever this is, you need to just paste it. Control V. Okay. We're done. Last one. So select everything and click on this execute button. It might take a while because the data set which was stored in Amazon S3 might contain large number of rows. So it might take a while. So as you can see, it states executing statement here. It says 1 out of 7 finished. So we have 6 more to go. So this SQL Workbench has successfully executed all the script which we have written here. Let's go and start performing some simple queries. Let's say I want to extract the metadata of user table. I have this query. Okay, select star from page table definition. So since we are extracting metadata from table name, let's say users, and click on execute option. So you have so many columns. Here it says first column user ID of type integer, encoding delta. Then you have username, first name, last name, city, state, email. So basically that's the metadata or the structure of user table. So we have sales ID, list ID, seller ID, buyer ID, and many other details. Let's execute some other command. Let's say I want to find total sales on a given date. Okay. Sum the count. Here I have some function which will count the number of sales from sales and date, where the sales date ID is date ID, and the date on which I want to calculate, I've specified it here, and then click. Okay, there's some error. It should show a number here. Rest is working, only that is not working. I've selected the user table and I've asked them to display all that there is in the user table. So this is the data. Okay, select star from users. So I want to extract the names of people who are from, let's say some states. Let's consider some state. Let's take NH. So STATE like NH. It should work now. It says executing statement. So these are the people who are from state NH. So basically, once you've the perfect connection from your SQL Workbench to your Amazon Redshift, you can perform whatever queries you like. So let's go back to our Amazon Redshift console. Well, so this is the cluster. I'm going to click on this. Here you have queries. When you click on that, all the queries which you performed till now will be shown. So this is the query. So it says first name from users who was from state NH. This was the query which we performed earlier. So you have all the data or all the information regarding the queries which you executed. Well, that's all about Amazon Redshift. So guys, this is how easy it is to create a data warehouse using Amazon Redshift. Go ahead and explore many other features of Amazon Redshift. Well, I've just showed a part of them here. So go ahead and create a database, perform various queries, and have fun. So guys, that's it. I hope the session was informative and demo fun. Go ahead and explore. And if you have any queries or doubts, post them in the comment section below. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!
Hey guys, welcome to this live session on AWS from Edureka. Today's session is going to be on autoscaling and load balancer. So today I'm going to tell you how you can autoscale your resources so that they become highly available. And this is what we're going to do today. So for those of you who are new to this session, guys, I want to repeat it again. If you have any doubts during the session, please comment it in the comment box. My team is here to help you out, right? They will clear all your doubts. Alright, so with that guys, let's start with today's session with the agenda for today. So guys, this is what we are going to do today. First, we're going to see what are snapshots and AMIs. So these are basically the entities using which you will be autoscaling your resources. So once you know what are snapshots and AMIs, we'll move on to why do we actually need autoscaling and what is autoscaling exactly. After that, we're going to see what is a load balancer, and towards the end, we'll be doing a hands-on, which is going to be very interesting because I don't think there's a demo out there which can show you the kind of demo that I'm going to show you today. All right, and if you think about it, guys, if you're thinking about moving to the cloud industry, autoscaling and load balancing are the very important topics in this domain, right? So you should know about them. So if you don't know about them, please pay attention today because you're going to gain a lot of knowledge today. All right, moving on, guys. Let's start with the first topic, which is snapshots and AMIs. So let us see what are those. So I guess most of you are aware of what an EC2 instance is. So for those of you who are not, an EC2 instance is just like a raw server. It's a fresh piece of computer that you have just bought. It's just like that, all right? So on that computer, you can choose any operating system that you want. So once you have the operating system, you can install any kind of software on it, all right? So you have to install every time you launch a new an EC2 instance, you have to install all the required softwares on it. All right, but there's a workaround. What if you want a specific configuration of EC2 instance? Say you want 5 EC2 servers which are exactly like this, like each other, right? So one way of doing that would be to launch a new instance every time, install the required packages every time, and going about it, right? The other way of doing it would be to actually create an image of, once you will be configuring your EC2 instance, and after that you'll be creating an image of your EC2 instance, and then using that image you can actually deploy 4 more EC2 servers. All right, so this image is basically what is an AMI. So AMI, which is an Amazon machine image, is nothing but an executable image of your already existing EC2 instance, right? But before an AMI can be created, there's a thing called snapshot. Now, what are snapshots? Snapshots are nothing but the copy of the data, the copy of the data that you have on your hard drive. So basically, if you have your C drive, right, and you want to copy your C drive, you copy your C drive onto some external drive, so that becomes a snapshot. But if you can boot from that external drive so that to your whole operating system comes up on some other machine, then it becomes an AMI. So this is basically the difference between the two. A snapshot is not a bootable copy, an AMI is a bootable copy that you have. All right, so I hope you got the difference between what is an AMI and what is a snapshot. So I'll repeat it again. And you use an AMI to basically replicate an EC2 instance again, so that you don't have to do the configurations all over again. Right, so now you'll be wondering, we were to talk about what is auto scaling, what is load balancing, why do we need AMIs? But be patient, you'll be clear with everything with the session. All right, moving on, guys, let's now discuss why do we need auto scaling. Now before that, guys, now the way I'll be going through this session is I'll be explaining you each topic, and then I'll show you it in the AWS console. All right. So we just discussed what are snapshots and what are AMIs. So let me quickly show you how you can configure or how you can create an AMI of an already existing EC2 instance in the AWS console. So give me a second. Give me a second. I'll just go to my browser and my AWS console. So guys, this is my AWS console. I hope it's visible to you. So the first thing that you'll be doing is you'll be going on to your EC2 console. All right, so in your EC2 console, you will have all your servers that are running right now. Right, so for the sake of simplicity, I've already deployed 2 servers, which are server 1 and server 2. Now I have configured them both with Apache so that they can they can host a website, right? So let me quickly show you how the website actually looks like. So if I'll go to this particular IP address of server 1, this is in path server 1. All right, so this is how the website looks like, right? Similarly, for my server 2, if I go into my server 2, this is how my server 2 will look like. Here it is. All right, so these are my 2 servers. Now what I want is I will create an exact copy of these servers so that they can be replicated. All right, so when I say replicated, everything from softwares to this website will be copied onto an image, and that copy or that image, when I will deploy it, it will be deployed inside one more EC2 server, in which I don't have to do anything. This website will be there. I just have to go to the IP address and I can see this website. All right, so now what I'll be doing is I'll be creating an AMI of both these servers. So let's create an AMI for server 1 first. I'll select the server 1, I'll go to actions, I'll go to image, I'll click on create image, and all I have to do is give an image name for it. So let me give the name as live server 1. Right, this is my image name. I'll click on create image, and that is it. It takes in your request for creating an AMI, and it does that. Right, pretty simple. Now similarly, I'll be doing it for server 2 as well. I'll select server 2, I'll go to image, I'll create an image, and I'll name the image, say, live server 2. So once I've done that, you can see the images in your AMI tab. So if you look at over here in the images section, you can look at AMIs. If you go to your AMIs, you can see there are two images which are just being created, which are in the pending state as of now, and they are live server 1 and live server 2. Now using these images, you can create any kind of server that you can create the exact same server with just a click of a button. Alright, you don't have to configure anything much. Alright, so this is how you create an AMI. Pretty straightforward, guys. Let's move on and discuss why do we need autoscaling now. So you learned how to create an AMI. Let's go ahead and understand autoscaling and see how they are connected to AMIs. Alright, so say you have an application, you have a website, and every machine, now this website is hosted on some server, guys, right? And servers are nothing but machines. Now every machine has its limitation, right? For example, say this machine is say around 8 GB and say i5 processor. So say it can host around 100 people, right? Only 100 people can come to this website and easily navigate inside the website. But if more than 100 people comes in, this computer or this server becomes slow. All right, so say there are 100 people as of now and they are trying to access your website, and they can easily access it. Now your website becomes a hit overnight. All right, and now a lot of people are trying to access your website, which makes your server overburdened. Now, in this scenario, you can do only one thing, that is deploy more servers and distribute the traffic equally among those servers so that the requests can be handled. All right. Now, this thing is a manual task, and manual is a big no in the IT world, guys. So we invented a service called autoscaling, and using autoscaling, what happens is it actually analyzes the kind of load which is coming in, right? And it deploys the servers according to that. So say around 300 people are coming in, and it sees that you need 3 servers to handle those kind of requests. It will do that automatically. Right, and that is where your AMI comes in, guys, because the new servers that you'll be launching, those new servers have to be taken out of some template, right? So the first server has to be the exact copy of the the second server has to be the exact copy of server 1. The third server as well has to be the exact copy of server 1, right? And that is where the AMI comes in. So what basically happens is, in the autoscaling service, you basically attach your AMI which you created, and using that AMI, it deploys more servers, right? This is why AMI is significant, or this is how AMI is related to autoscaling, and this is why do we need autoscaling. Let's move ahead and just give us a definition that what autoscaling exactly is. So like I said, whenever your load increases and you have to scale automatically up and down, you use autoscaling. So it's not only about scaling up, that is when your load increases, say 3 or 4 servers you have deployed, and when your load decreases, still 4 servers are there sitting idle, right? So that is not the case. With autoscaling, you can also scale down as per your needs. You can configure everything which you can imagine about scaling up and scaling down in the autoscaling properties. All right, so this is why we need autoscaling. Now, one more thing that you need with autoscaling is, if you would have noticed, I said the number of servers that gets deployed in the autoscaling. Say there are 4 servers which get deployed during autoscaling, right? Now the traffic has to be distributed equally, right? So this traffic which has to be distributed has nothing to do with autoscaling. It has to be done by a separate entity, and that is what we are going to discuss in the next section. But before that, let me show you how you can configure the autoscaling properties and attach the related AMI so that the related servers are launched. All right, so let me go to my AWS console. So here am I, and as you can see, the AMIs have already been created. They are live server 1 and live server 2. Now what I'll be doing is, I'll be creating autoscaling groups, or I'll be configuring the autoscaling properties so that these servers can be autoscaled as and when required, right? So before that, I actually have to create a launch configuration. Now what is a launch configuration? So if you look at the AMI, guys, you have only specified what kind of data should be there in your server. What you have not specified is what kind of machine you should launch every time there's a need. All right, so that is exactly what you do in launch configuration. So you have the data, but you don't have the information about the kind of machine that you want to launch. So that kind of stuff you'll be specifying in the launch configuration. So what I'll be doing is I'll click on create launch configuration, and now it'll give me a wizard as same as that of any EC2 server. Right, in the EC2 server, I had to choose an operating system, right? So same, it'll give me the wizard, but I don't have to go here. I'll have to go to a separate tab which is called My AMIs, right? So I'll select My AMIs, and now I'll select the newly created AMI, the AMI which I just created, which is say we are creating a launch configuration for our server 1 right now. So I'll select the live server 1. I'll click on select. And now it will ask me the kind of the configuration that I want for my server, right? So I need a t2.micro because we are doing a demo today, right? So we don't need much of computing power. So we just have to we'll select t2.micro and we'll name our launch configuration a thing. So let's name it as live server 1, right? And the IAM role is not required, and I'll click on next. Now it'll ask me for adding the storage, so 8 GB is enough for an Ubuntu machine. I'll go to configure security groups, right? And in these security groups, I just have to add the HTTP rule because I have to connect to all the instances that I'm launching, right? So I'll select the HTTP rule from here, right? And I'll click on review. So that is it, guys. Nothing else has to be configured here. All right, and it is asking me to check everything that I've just configured. Everything seems fine. I click on create launch configuration. Now it will ask me for the key pair, right? So every server which will be launched, it will be associated with the key pair which you'll be specifying here. All right, you can create a new one if you don't have already. I already have a key pair, so let me choose my key pair. So that is Hemant_2, and I acknowledge that I have this key pair, and I'll create the launch configuration. It just takes a second or two to do that, and we are done. All right, so now we have created a launch configuration. We have specified what kind of machine we want. We have specified what kind of data should go into that machine. Now we'll be creating the auto scaling group in which we'll be specifying in which cases we want to auto scale. All right, so let's create an auto scaling group now. All right, so it has automatically picked up the launch configuration that we have just created, that is live server 1, right? Let's name this group as live server 1 group, right? And what is the initial size that you want in your launch configuration? That is the minimum number of servers that you want. So let it be 1. And remember, guys, this is the most important part. When you are creating a launch configuration, ensure that you're doing it in your default VPC to be on the safe side, because there are a lot of settings that you have to do if you create a VPC on your own, and that becomes a hassle. All right, so if you accidentally delete your default VPC, which I did, right, so you have to contact the AWS support team and they'll help you out with it. They'll basically create one for you. You cannot create one on your own. Right, so always ensure that you are in your default VPC whenever you're creating your auto scaling group. All right, so now I'll be specifying the subnets. So basically you have to select a minimum number of 2 subnets, right? I'll be not getting into what are subnets because then it will be like a 3-hour session. We'll click on configure scaling properties. Now over here you can specify the properties that I was talking about. When do you want your server to scale, right? So over here you can specify the average CPU utilization. Now what do you mean by average CPU utilization? Say there are 4 servers running as of now, right? So it takes the average of all the 4 servers, right? And if the average goes beyond whatever number you have specified here, say I specified 70 over here, right? So in that case, whenever the average CPU utilization will go beyond 70, it will launch one more server. Similarly, if it goes, I can configure one more property here, which says if it goes below 20%, like scale down from one server. All right. So if there are 5 servers and the CPU utilization has gone less than 20%, it'll scale down from one server and come down to 4 servers. All right, and you can also set how many seconds should it wait. Say the traffic is spiking down and up like too frequently, right? So for that, what you can do is you can set a time. So if the 20% mark has been not crossed till say like 5 minutes, then it will scale down a server. Or if the 70% mark of the CPU utilization has been crossed over 5 minutes, it will then only scale up. It will not scale up if at only once for only 1 second it becomes 71%. All right, so you can specify all of that over here, but since I cannot load test my instance over here, I'll just keep it at its initial size, which just means that it'll, even if I delete my instance, that is one instance has to be there in any case. If I delete the instance, it will automatically launch it again. All right, so we'll select the keep this group at its initial size, and we'll go to configure notifications. So I don't want to configure the notifications, neither the tags. I'll click on review and I'll click on create auto scaling group. All right, so I've successfully created an auto scaling group for my live server 1. All right, similarly I'll do the same steps for my server 2 as well. I'll click on create auto scaling group, and I'll select a launch configuration which was there for my server 2. So I've not done that, so let's create a launch configuration first for our server 2. We'll go to AMIs and we'll select the server 2 part here. Alright, so I've selected server 2. I'll do the same steps that I did earlier, right? So let me give it the name as live server 2 group. I'll click on add storage, configure security group. Over here I'll add the HTTP rule, click on review and launch configuration, select the key pair, acknowledge it, create launch configuration. I'm doing the same steps, guys. I'm not doing any new thing here. I've created the launch configuration. Now I'll create the auto scaling group, which is live server 2 group, right? And then the VPC, as I said, should be default subnets, a minimum of 2 subnets you should select. I'll click on scaling properties. I'll keep it at initial size, configure, review, and create the auto scaling group. All right, nothing much, guys. So same things that I did for my server 1, I've done for my server 2 as well. All right, so since I've created an auto scaling group, if you go to your EC2 dashboard, you would notice that 2 more servers are now being deployed. All right, so you can actually identify them over here. See, these 2 servers are being initialized. So these have just been created by your auto scaling group, because we've specified that a minimum number of 1 server should be there at all times, right? Now if you try to go to the IP address of this server, right, you will see that it will have the exact same settings for my EC2 instance. So this is my server 1, right? So as you can see, a new instance got created, but with the exact same settings. I didn't have to do anything. It automatically created an instance with the same settings. All right, and same is the case with server 2 as well, guys. If I go to my server 2 and try to access it, I'll see the same things over there as well. So I'll show you in a bit. Yeah, so this is my server 2. All right, so my auto scaling group is functioning fine. So let us come back to our slide now. So we are done with auto scaling. Now, like I said, you need to have an entity which will equally divide the traffic between the servers that you've just deployed. All right, so they say I've created 2 auto scaling groups, guys, as of now, right? Why I've created a second auto scaling group, I will tell you in a bit, but for now understand that there is an auto scaling group. All right, and inside that auto scaling group, say there are 5 servers, and if a person is coming in, or a customer who has logged on to your website is coming in, how would his traffic be treated? How would he know which server to go to, right? So there comes in the third entity, which is called the load balancer. So what load balancer does is, a load balancer, your customer will basically be coming to your load balancer, and the load balancer will decide based on the usage of your servers that which server is more free, and then will give the connection to that server. All right, so this is basically the role of a load balancer. So like I said, a load balancer is a device that acts as a proxy and distributes network or application across a number of servers. Now, I've been saying it repeatedly that your servers are actually your traffic is actually distributed equally among the servers, right? But in a few moments, I'll tell you that there is one more way of distributing your traffic. Alright, so before that, let me again stress on the point that this was your auto scaling group, guys. This is just the example that I took in the beginning, right? So there are like these set of users, and they're trying to access your website, and they are being routed to these servers. So this routing is actually done by a load balancer. Alright, now like I said, the traffic which is distributed, it is distributed in two types, right? The first type would be to equally distribute them among the number of servers. Like say there are 5 servers, so it will distribute it among the 5 servers. But if there are there are two kind of servers now, so your load balancer can identify what kind of request is being made by your user. For example, in your website or in your application, you have a part wherein you can process the image, right? And you have a part where you have your blogging section. All right, so if you want to process the image, you want your traffic to go to a different set of servers which are auto scaled at their own in their own auto scaling group. All right, and if you have the blogging section, you have a different auto scaling group which is auto scaled at a different with a different auto scaling group, but you want everything to go from one single link. So the way to do that is using an application load balancer. So let me just repeat what I just said. So say this set of servers, they host your image processing part. They do all your image processing, and these set of servers, they host your blogs that you have on your application. All right. A user comes in, he just logs on to your website, and he goes to a URL which says, say, edureka.co/image. All right. If he goes to /image, your load balancer will see, okay, he's asking for the image kind of content, so he should go to this set of servers because these servers serve the image purpose. And if you go to edureka.co/blog, your load balancer will identify, okay, this user, he is asking for the blog content, so he should go to this set of servers. All right, so all of that is done using your load balancer. If you compare it with the classic load balancer, it does not have that kind of intelligence, right? What it will do is basically all the traffic that it has got incoming to it, it will equally distribute it among the number of servers that are under it. All right, but with application load balancer, you have this option wherein you can divide the traffic according to the needs of the customers. All right, now when you have divided the traffic, again the same thing will happen here as happens in classic load balancer, that at this point it will equally distribute the traffic among the number of image servers, right? And similarly, the people who want to access the blog, it will equally distribute the traffic among the number of people who want to access the blog server. All right, so this is what an application load balancer is all about. So classic load balancer was something which was invented earlier, and these days nobody uses the classic load balancer anymore. People are using application load balancer. All right, and that is what our demonstration is going to be all about today. All right, so enough of talks. Let's move on to the hands-on, that is the demo part. So let me quickly show you what we are going to accomplish today. So basically, a user will come in, he will have the address of your load balancer, and if he asks for the image path, or say server 1 in our case, he will go to the auto scaling group of server 1. If he asks for server 2, he will go to server 2, but all of them will have the same address, that is using your address of your load balancer. All right, so this is what we are going to accomplish today. Now, for those of you who didn't understand that why did we create two auto-scaling groups, is because we want these servers, that is the image processing servers, to be scaled as well, and at the same time we want the blog servers to scale as well, right? So that is the reason we want we created two auto-scaling groups. So I created a server one, which you can imagine is for your image processing, and I created an auto scaling group for server 2, which you can imagine is for your blogging section. All right. Having said that, guys, now let's move on to my AWS console and go to our load balancers. All right. So what I'll be doing now is I'll be creating a new load balancer, and that load balancer would be of the type application load balancer. So as you can see, I have two options here. Either I can create a classic load balancer, or I can create an application load balancer. So I'll go on with the application load balancer, and I will name it as live load balancer. And the scheme is internet facing. So since mine is a website that I want you guys to access, right? So it could be internet facing. Otherwise, if you are working in a company and that company wants a load balancer for their internal websites that the companies have, you can actually opt for an internal load balancer as well. But since ours, we have a website and we want that to be used, we will use the internet facing load balancer. All right, and the listeners, it's HTTP, that's fine. And the availability zones, like I said, you have to select a minimum of 2 availability zones, and you'll click on configure security settings. All right, so now you'll be specifying the security group, right? So in security group, it's better to create a new security group. Remember, guys, don't include the default security group for your load balancer. It's a good practice to always create a new security group so that you can customize your rules according to your needs. All right, so I'll create a new security group and specify the HTTP rule, and I'll click on next. And now comes the part wherein we'll be specifying the targets. All right, now what are targets? Now in application load balancer, guys, targets are basically but auto scaling groups. All right, so target 1 would be your auto scaling group 1, your target 2 would be auto scaling group 2, target 3, target 4. You can have as many targets as you want, but in this wizard you have to specify a minimum number 1, right? So we'll create a new target group. We'll call it as say auto scaling live auto 1. All right, and the protocol is HTTP, port is 80. We'll click on next, and I'll review everything. I think everything is fine, and I'll create this load balancer. All right, so we have not done all the settings, guys. I'll show you how to do all the settings. For now, we have just created a plain load balancer. All right, so I have created a load balancer which is pointing to a target group 1, and that target group is not pointing to my auto scaling group as of now. All right, we will do that now in this part. So we have created, I just created a target group called live auto 1. I'll create one more target group which will be called live auto 2 for my second auto scaling group. All right, so I'll create this and done. So I now have 2 target groups, that is live auto 1 and live auto 2. Now these 2 target groups have to point to my auto scaling groups respectively. All right, now the way to do that, you cannot point them here. You have to go to your auto scaling groups, right? And in your auto scaling groups, you have to select the auto scaling group that you have just launched. So it is live server 1 group and live server 2 group. So I'll go to live server 1 group. I'll go to details, and over here you'll click on edit. All right, and inside edit you have this option for target groups. You don't have to specify anything in the load balancers. This option is only for classic load balancer, but we are creating an application load balancer, right? So we'll be specifying everything in the target groups. So for live server 1 group, we'll be specifying the demo server 1. So demo server 1 has already been it will be live auto 1, the target group that I just created, and live auto 1 is connected to your load balancer. So basically your load balancer will point to your target group, and your target group is now pointing to your auto scaling group 1, which are pointing to your instances. All right, so this is how the visibility comes in. So I'll save it. The target group 1 is live server 1 group, and the target group 2 I'll be specifying in the second auto scaling group, which is here, that is live auto 2. All right, I'll save it, and let me quickly verify if I've done everything right. So this is live server 1 group, and this is live auto 1. Fine. This is live server 2 group, and it is live auto 2. Fine. So my load balancer can now see the auto scaling groups that I've just configured. So let me quickly go to my load balancer. Now comes the part, guys, wherein I'll be specifying when to go to auto scaling group 1 and when to go to auto scaling group 2. Like I said, we'll be specifying it using the kind of request that the user has made, right? So the way to do that is is by first selecting your load balancer and going to listeners. So once you go to listeners, guys, you will reach this particular page. Now in this, you have to click on view or edit rules. Right, so once you click on view or edit rules, you will reach this page, which is kind of an if-else, if-else structured. So now what will you do is, so you can see that there's a default rule as of now, that any request which is made, it will go to live auto 1. All right, which means any request which is made, it will straight away point it to the auto scaling group 1. Now we'll specify if the request if the user is asking for server 2, he should be pointed to server 2. So let us do that. The way we'll do it is like this. We'll click on add rules. We'll click on insert rule. And now I'll specify. So you have two options here. Either it could be the routing could be based on your host, that is the address of your website, or it could be based on the path. Now what is the difference? Say edureka.co, this is a host name, right? Now if I type in resources.edureka.co, it'll still point to my domain, but if I've specified resources.edureka.co, and if I write it over here and I specify it has to go to server 2, it'll go to server 2. Otherwise, if you type in resources.edureka.co, nothing will happen because you've not configured anything, right? So that is the host path. With paths, the difference is that say you write edureka.co/blog, all right? So that /blog becomes the path. But with host, the thing is, the difference is resources.edureka.co. So that becomes one host name, right? But with path, you're basically putting a slash and you are going into a particular folder. All right, so you can specify the path here. All right, it doesn't matter if you have not specified in your server for different you could the way you could have done the image processing and blog the other way around, rather than having it on two servers, was that you could have configured it inside two servers in your root directory, right? It could be server 1 for your image processing and server 2 for your blogs. But I don't want that, because as distributed as your system is, it becomes more reliable, right? And that is the reason we have two different servers for two different set of things. So the way you can route your traffic to both these servers is by typing in the path. So say if I have to go to server 1, I'll type in server 1/*. So star basically means anything after server 1 can be accepted, but it has to go to the request will be forwarded to live auto 1. All right, so if I have server 1 in my path, anywhere in my path, it will go to live auto 1. So I'll save this rule. Similarly, I say that if it has server 2 in its path and anything after that, it has to go to live auto 2. All right, I'll save it. And that is it, guys. Now my load balancer has saved its settings. Let's hope for the best and try executing it. So this is the link, guys, right? If you just type in this link, it'll by default go to server 1, right? So if I go to this link, you can see it is going to server 1 as of now. But if I specify /server1, it'll go to my server 1. And if I specify /server2, it'll go to my second server. Now you might be wondering that Hemant, you might have a different directory in your same server. So let me clear your doubt according to that. So what I'll do is I will go to my EC2 dashboard, right? And I'll go to server 1 and I'll quickly show you what happens if I type in server 2 here. All right. So this is the IP address, right? So if I type in this IP address, I'm going to server 1. If I type in /server2, it will give me a 404 because there is no folder called server 2, right? Same is the case here. So if I go to this IP address, you can see server 1. If I don't specify anything after my address, it will still go to the same server that is here, that is this IP address, right? But if I specify /server2 over here, it will not be able to do so because this is not a load balancer, it is directly your IP address. But over here, if I specify server 2, it will redirect me to the second server. One second. Right, it will redirect me to the second server. And that is all that I need. All right, so with one address, you are actually pointing to 2 servers, which will be solving your 2 problems. Now, the real life use case, like I told you, it could be for different kind of tasks. Say you have a blogging section on your website and you have an image processing section on your website. If you want 2 different servers to host your 2 different services, you can do that easily using a load balancer. Alright guys, so with this I conclude my session for today. Let me quickly go to my my PPT. So we created we created a load balancer which intelligently identifies what the user is asking. If he's asking for image, he'll go to server 1. If he's asking for blog, he'll go to server 2. In place of image, I've just specified server 1 and server 2 so that it becomes easy for you to understand. All right. One more part that I missed. Whenever you have specified the path, that path also has to be specified in your server. For example, I said load balancer address /server1. Right, so it will go to your server 1, but then over there it will look for the server 1 directory. All right, similarly, if I specify /server2, it will go to second server, but it will look for the server 2 directory. So keep that in mind. All right, guys. So with that, I conclude today's session. Thank you for attending today's session. I hope you learned something new today. Now, before ending the session, guys, I would quickly like to point you out to the content that we have on our social platforms for free. All right, so if you are more keen to learn more about AWS, right, you can go through our blogging section. It's over here. It has around 11-12 blogs which are enough to give you a kickstart into the AWS world. Similarly, we also have a channel on YouTube which has around 48 videos for you to go through, right? These videos are updated frequently. You can go through all these videos and learn more about AWS. We have came up with a new course for the Cloud Architect program, which basically means for today, if I do a certification on AWS, that is not enough. That is not enough for me to get hired in the industry, right? So I have to know a host of different technologies as well. So there comes in my DevOps, there comes in maybe a programming language and everything. And we at Edureka, we understand that, and hence we have came up with a curriculum which will not only teach you cloud computing, it will also introduce you to topics on DevOps, it will introduce you to topics on programming, right? And it will also introduce you to a secondary cloud provider which you should always have, which companies prefer, and for that we have Azure. right? So you can go through the course details over here, right? And again, if you just want to opt for our AWS course, you can do that over here. You can see the batch timings, and we have flexible batch timings for every class that we have on Edureka. We understand that you as professionals, you don't have time during our office hours, so we have morning timings and evening timings as well, so you can choose the time according to your will. And if you want to know more about the course, you can go to this course description section and know more about the course. All right. Regarding the live session, guys, I would like to fill in a survey for the work that we are doing for you guys. If you like the work, please specify it over here on this page. I think my team will be passing on this link to you in the comment box. Please go through that link and fill in this page so that it becomes easier for us to help you out in learning more. All right. So with that, guys, I conclude today's session. Thank you for attending today's session. Have a good day ahead. Goodbye.